Thank you. Now, I would like to request Professor Sridevi Madam, Head Department of Physical Sciences and formerly Head of the Department of Pharmacy, Sri Padmavati Mahila Vishwavidyalaya, to give welcome address.
Thank you, sir. Thank you very much. Respected chief guest of the webinar, Professor A. Jyoti, Dean School of Sciences. Today's eminent speakers, Professor V. Vasudev Rao Garu, IIT Kharagpur, and Professor C.K. Jayasankar, SVU, Tirupati. Professor Krishnaya, Coordinator of Physics Department, Chemistry Department Coordinator, Professor Subramanyam Garu, faculty members of Physical Science Department, my dear students and participants. Warm welcome to National Webinar on recent trends in energy storage materials and its applications. As a formality, first I have to give a brief introduction of our physics department. And this physics department was established in 2004 and it is offering MSc Physics PG program, and it is initiated with the 15 students intake, and gradually the intake was increased, and current year the intake of the students is increased up to 60. And the department is constitutes of one coordinator and 4 young and dynamic faculty members. And the PG program of this MSc is designed in such a way that the students are trained as well as the advanced knowledge in the physics. Although the program is self-supporting, but it caters the educational needs of socially and economically backward sections of girl students of rural areas. Till date, 16 batches of students were successfully completed their PG and they all are placed well. And regarding the webinar, the title of the webinar is Opt for the Present Situation. So the energy storage technology have a significance in synthesis, fabrication, structure, properties, performance of material and their devices. Energy storage technology is a breakthrough to the electrical generation and user. Simultaneously, it is the future of conventional electrical energy technology. In recent years, both and engineering and academic research have grown in this area. So due to this, we opted this title to organize the webinar to enrich the participants with profound knowledge in the recent trends and energy storage materials and its applications. I especially appreciate the coordinator and physics department faculty members for conducting this webinar within a short span of time. Thank you very much. Thank you, sir. Thank you for giving the opportunity for this. Thank you.
Thank you, madam. Now, I request Mrs. Basamma to introduce our chief guest, Professor A. Jyoti, madam.
Thank you, sir. Good afternoon to all of you. Myself, Mrs. S. Basamma, faculty from Physics Department. Now, I would like to introduce today's our chief guest, Professor A. Jyoti Ma'am, Dean, School of Sciences. She received her PhD in Food Science and Nutrition from SNDT Women's University. She has both teaching and research experience more than 35 years. Till now, she has guided 10 PhD and 1 MPhil students. At present, she is guiding 8 PhD students and 1 MPhil student. She has published 14 scientific research articles in various reputed journals, and she wrote and published 5 books and various titles.
Thank you, Asamma.
And finally, thank you, sir.
Okay. I request our chief guest, Professor Jyoti Madam, to address the gathering.
Thank you, Basama, for your nice words about me. And good morning to everybody. And today's president and head Department of Physical Sciences, Professor A. Sridevi Garu, coordinator Department of Physical Sciences, Professor Krishna Garu, and coordinator of Organic Chemistry Department, Professor Subramanian Garu, and my dear faculty members, and today's speakers, eminent speakers, Vasudev Rao Garu and Ranga Rao Garu, and my dear students and friends. Very good morning to all of you. I congratulate the Department of Physical Sciences for organizing this today webinar, national webinar on recent trends in energy storage and its material and application. I think within a short span of a time, they have arranged this program, but it is very nice and apt topic for the today's situation. And the energy which is turned from many things, like it can be a chemical energy, thermal energy, mechanical energy, so on and so forth. And since I am a nutritionist, I would like to say a lighter side of this energy, which is chemical energy after eating of different types of a food, like a carbohydrates, proteins, fat. The energy will be released and stored in the form of a ATP in our body, and it is used for our expenditure. Suppose in case, like a other side of the thing, if we produces lot of energy through mechanical, chemical, or thermal, or so and so, it can be used, it can be stored and used for a later period. But in case of our human body, if it is stored for a longer period, it can be stored as a fat in adipose tissue. And we know that what happens if it stores excess of a fat in our body. So that's why we have to, the generated energy from our food sources has to be utilized optimally for the whatever activity we do, physical activity, mental activity, and as well as the basal metabolic rate, etc. It has to be balanced. Otherwise, it will leads to a ill health. That all we know that it is excess of a fat is accumulated in adipose tissue and causes the obesity, overweight and obesity. This may be a predisposing factor for many of the disease conditions. So we have to be more cautious about it and not to be stored in body. And that is the thing we have to see in case of this human body and its structure, etc. So if we store the energy in our body, it will be so difficult. But we have to take the energy in optimum levels to do our day-to-day activities in the optimum way, and in a to keep our body in a healthy and well-being. So that's why this is the lighter side of it. So don't think otherwise. And other energies can be stored and it can be utilized in a later span of the time for many other purpose, like solar energy can be stored and it can be utilized when it is required. There's other things like any energy, mechanical energy, all those things, and energy in batteries also we can be stored and can be used for a longer period, but not in case of our human body. The energy cannot be stored, but it has to be balanced, and whatever we intake should be expenditure, it should be balanced, then only we can keep our body in healthy well-being. So just to myself to fit into this webinar topic, I said about all these things, and I congratulate once again the Department of Physical Sciences for conducting the topic for today's generation, and I uh, wish all the participants to learn from this webinar and use it for other in future purpose, and generate new ideas to generate energy from different sources. There are a number of things, any number of materials are there which can be used to generate the energy, like a wind can be used, water can be used, whatnot. Speed during while the vehicle traveling also, in a bumps, in a speed breakers, etc., the energy will be generated. That can also be used and can be stored. We have to see that how it can be stored in a different materials, and it can be used for the later purpose. So once again, congratulate the department and faculty, students, etc. And I thank the organizer for giving me this opportunity. Thank you all.
Thank you, madam.
And all the best.
Thank you, madam, for your nice talk, combining the biological energy into the recent trends of energy storage, really materials. It is really relevant and very nice talk. Thank you very much, madam. Now, I will
Thank you.
The inaugural vote of thanks. So, I am Professor M. Krishnaya, Coordinator, Department of Physics, Sri Padmavati Mahila Vishwavidyalaya. Respected Chief Guest, Professor Jyoti Madam, and my beloved Head of the Department and President of today's this webinar, Professor Sridevi Madam, and very eminent professors, distinguished student scientist, Professor V.V. Rao, IIT Kargapur, and my another very distinguished scientist, spectroscopist, photonic scientist, Professor Jayasankar, and my dear all attendees of this webinar. Good evening to all of you. And I take this opportunity to propose vote of thanks to all the people who are all attending this program. At the outset, I would like to take this opportunity to express my deep sense of gratitude to Professor Jamuna Madam, Vice Chancellor, or beloved Vice Chancellor of Sri Padmavati Mahila Vishwavidyalaya, and Professor Sandhya Rani Madam, Rector, now presently Director for IIIT Madam, who have guided us from the beginning to start the programs in the Department of Physics. And I would like to thank our Professor DM Mamta Madam, Registrar, and Professor R. Nagaraj Sir, Dean Development, and Jyoti Madam, Dean of Sciences, and all the university administrative staff who are all helping from time to time. And I would like to thank Professor Sridevi Madam, who have readily accepted, who have encouraged to start this webinar with using her Zoom timing to propose this the recent trends in energy storage material seminar. I thank you, Madam Sridevi Madam, for all your guidance, and I thank our chief guest. Who have spending their valuable knowledge and time to impart the important knowledge recently, particularly in the energy sector. Really, it is our fortune to have VV Rao. He is an expert in low temperature work and as well as in superconductors. So one must maintain low temperature to achieve the superconductivity. And the superconductivity nowadays for the energy storage, and all the technology, how is it advancing? And everybody needs a very lightweight and more memory and more speed materials for their cell phones and even the computers for such field. And here our scientists, Professor V.V. Rao, Vasudev Rao, will give a talk, very, very useful talk for energy storage and energy storage material. Similarly, Professor C.K. Jayasankar sir also is going to give very, very, very useful talk on rare earth, uh, uh, rare earth doped materials for energy storage and photonic applications. I really thank you very much, sir, for your readily acceptance and going to deliver the lectures today. So thank you very much. Now I request our colleague, our Subhashini, to introduce the present speaker, Professor Vasudev Rao.
Thank you very much, sir. It is my immense pleasure to introduce Professor V. Vasudev Rao, sir, currently working as a visiting professor, Cryogenic Engineering Center, Indian Institute of Technology, Kharagpur. He was completed post-graduation in SV University and awarded PhD in Indian Institute of Technology, Madras. He has given 8 PhDs and 1 postdoctoral fellow. He is a life member of Indian Vacuum Society, member in IEEE, and fellow in Indian Cryogenic Council. He published 101 papers in international and national journals and authored a textbook of vacuum science and technology. He was handled 9 projects funded by Ministry of Power, DST, CSIR, FIST, IPR, and 12 consultancy projects, and 2 projects was in progress. His research areas are in high TC superconductors for power applications, vacuum technology for process applications, cryogenic engineering, and low temperature physics. Now I'm inviting Professor V. Vasudev Rao, sir, to start the talk.
Thank you.
Thank you, sir. Hello. Hello, sir. Are you hearing, sir?
Hello. Am I audible?
Yes, sir. Yes, sir.
Am I visible?
Yes, sir. Yes, sir.
Okay. Because I'm not able to watch here, but anyway. Okay. Thank you very much for nice introduction, and it is my pleasure to be associated with all of you for delivering a lecture on superconducting magnetic energy storage and its applications.
Share this one. Hello, sir. Sir, your voice is not hearing, sir.
Hello, there was
yes,
a link problem.
Okay.
I think it might take, but meanwhile, I am coming back to the other mode of cell phone. Of course, these are all the modern problems.
Yes, sir. Yes, sir.
And of course, the problem is technology. And to overcome this problem also, we need technology. So we have to, this is a way, I think it is also scientific. Okay,
Yes.
so nothing to get worried. Let the problems come, let us face, and let us overcome it. Now our within IIT that internet is coming. Maybe I will switch over to this. So all this, all of us are used to it because this is not a seminar, it is a webinar. So there will be problems. So I would prefer directly you put the slides one by one, and I will go to the only audio mode now, so that people can concentrate because it is worthwhile if you try to understand things from the slide as well as from my words. Okay, so you don't have to look at me for understanding the things. So all of you are able to see the slides.
Yes, sir. Yes, sir. It is visible, sir.
Okay. Okay. The first slide. Madam, I will tell next slide, please. At that time, you kindly do it.
Yes, sir. Yes, sir.
So till that time, I will be talking on that. Okay. So the topic given to me is superconducting magnetic energy storage and its applications. I have, I think, maybe 1.5 hour time. So I will try to finish it as early as.
Change.
I would very much wish to explain physics and its applications. Okay. Particularly, I wish this is very useful to student members because they are going to be the future scientists and engineers, because all the modern technologies, when they really come up to the market, it is only the next generation who can utilize it properly. So we should, it is our duty, all our professors and administrators, etc., to see to that the students are understanding these things properly and they can excel in these fields. There are many fields which are very equally good, and I am concentrating on superconductivity. And within superconductivity, I am concentrating today on energy storage aspects of superconductivity. There are various other aspects of superconductivity, but today that's not the aim. Maybe some other day I will try to talk on magnets, superconducting magnets for MRI, superconducting magnets for nuclear fusion, particle accelerators. That's a different game altogether. So to start with, let us come to superconductivity first. Then we'll see energy storage, etc., etc. Well, super is a word everybody likes. No, when man becomes very good or very efficient, you will call him as Superman. When market becomes very good, then we'll say supermarket. And when the bus or anything is very good transport, we'll say it is super deluxe. And when the trains are very good, we'll say super express. So super fast express. The super word, somehow it has gone into our mind that whenever we see efficiency or whenever we see something great, we call it as super. Okay. So same thing in superconductor. Conductor of existing conductors, if some conductors are very good, then we can call them as superconductors. Since we are talking conductors, not materials word, we will be confining to electrical conductors. Tomorrow, somebody else will talk strength of material or a very iron, steel. They're also very important materials. That time, we don't call them as conductors. We call them as structural materials and then go about mechanical properties, etc. So since we are talking superconductors, we will identify ourselves with electrical conductors. Electrical conductors, as of today, all of us know copper, aluminum, silver, gold, etc. But if you say electrical materials, you should also include insulators, dielectrics, semiconductors, etc. But conductors popularly means which conduct electricity. And superconductors means it will conduct extremely well. Extremely well means what? If there is no resistance for electrical flow, electrical current, then we call it as superconductor. That means resistance must be zero. If you want to do something and if there is no resistance, that's the best way. You don't have to have much effort to overcome that. You're very good experts who talk in religious organizations. The way they speak, we cannot speak because they effortlessly they speak. Because they can, effort is less, but effect is more. In superconductor, the energy input is not much, but resistance to the effects of super electric flow is very good. Resistance is very low, and we can really store energy utilizing these superconducting materials. Anyway, all this general introduction, why I'm telling is to pass some time so that all of you get used to it and what's so great about super, etc. Otherwise, if I keep on talking slide after slide, you will also get bored, and I will also take some time to come to tempo. This is generally we do in classes also. All the teachers know very well. Okay. Now, if you look at the right side, bottom, there are copper conductors, very big conductors. Somebody's hand is there on that also. So that can carry some 500 ampere current. But when you use superconductors, that much cross-sectional area can be reduced by few strips, almost like our tongue cleaners. That means some 10 types of tongue cleaners can carry the same current as a bulky copper cables. That means 100 times cross-sectional area is going down, but still we'll have same current. Very good. Then what is the immediate advantage? Volume will be very less. And another advantage is R is 0, so I square R is 0. I will not go into very elementary aspects because this is in physics department. So all of you know I square R 0 means Joule losses are not there. There is no heating effect of current. So entire energy can be stored. If you can bend this wire in the form of a coil, then with an inductor L, then there can be energy storage called half Li square. So this I square R, half Li square, these are all taught in 12th class, electricity and magnetism. Heating effects of electricity, I square R, etc. they are told. That is in 3rd or 4th chapter. Then magnetic effects of materials also is told. So all these things are 4th to 8th to 9th chapters of class 12. But we need to revisit them when you are going for materials of advanced materials. So we are actually taking advantage of R is equal to 0 and realize some applications for our day-to-day life. To make things simpler, one application which you might have seen, but I don't want you to see, is MRI, magnetic resonance imaging. I don't want you to see because I don't want you to enter into hospital with a disease. But if you enter, you will find a superconducting magnet in that room. It is only because of high energy storage in a magnetic coil without any loss. Physics people know very well, L by R constants, etc. When resistance is not there, current continues to flow in a ring without any reduction. That's called persistent currents. Exactly these persistent currents are used to produce enormous magnetic fields of the order of 2 Tesla in a small lab room, clinical room, where the body goes through that tunnel, magnetic tunnel, and because of nuclear magnetic resonance effects, of the protons that are there in our body and comparing it with the similar images of sick as well as healthy patients, we'll get lots of interpretation of MRI, and accordingly doctor decides what to do. So it's a beautiful application of superconductivity. It is possible because R is 0. And there is huge amount of energy stored in that coil in the form of half Li square. But that's not the energy storage I will be talking after some time. What I will be talking, as somebody has already pointed out, the energy storage that is required for electrical power sectors. But to get a feel of it, I have introduced you the superconducting magnet used in our hospitals. Who has discovered this material? It is very important for us to pay tributes and honor to the people who have discovered. 60 years back, Bodin, etc., they have discovered semiconductors. At that time, nobody bothered, what is there in these materials? And they were trying to do something, and if you change the temperature, resistance decreases. If you increase the heat temperature, and if you decrease the temperature, resistance increases. That's why it is called semiconductor. But in a metal, if it is a reverse effect, if you increase the temperature, resistance increases. And if it is insulator, it is more or less constant and very high value. So different materials have got different variations of electrical resistivity. So one of them have discovered semiconductors. So what? That's what people thought 60, 70 years back. But today, this webinar is possible because of mobiles, because of laptops, because of communication network, because of solid state devices. Entire life is now totally depending on semiconducting devices. So they have not thought that physicists who have discovered semiconductors 60, 70 years back, they have never thought this will happen. Similarly, the superconductor, when it was discovered by Kamerlingh Onnes in 1911, that is more than 100 years, 110 years, he never thought that a day will come that a university will organize a conference on it or webinar on it. But he is pretty sure that a day will come when electrical engineers will be using it left and right. That's what he thought. But it took 70 years, nothing happened. 1911, he discovered superconductivity and he got Nobel Prize for it. Very good. But 70 years, nobody bothered about it, excepting MRI, because for which there is no other alternative. So you have to have that conventional superconductors, which are very costly, which need to be cooled to very, very low temperatures. So all these situations, electrical engineers are not interested. So they said, so what? If it comes to room temperature, then we will replace copper or aluminum with the superconductor. Till that time, we are not bothered. But God will not keep quiet. God has not created conductors or semiconductors or superconductors just like that. He has an aim for it. He knows how to navigate these materials into the society. So if you look at the middle curve, middle figure, around 1986, a breakthrough happened. That you started getting some materials which are superconducting at very high temperatures. Very high means relatively high. There is nothing called very high. For us, 100 degrees centigrade is very high. But for a furnace people, 1000 degrees centigrade. If you go to sun, million degrees centigrade. So we need materials which are superconducting in our day-to-day life in room temperature. So physics professors, physics research scholars are struggling for the last 100 years towards that goal. And as of today, they have come up to almost 150K, 160K. And recently there was a big news that room temperature under high pressure, there are certain materials which are superconducting, but technology is not that easy. So as of today, comfortable technology is 150 Kelvin. 150 Kelvin is a convenient temperature for most of us because there is one refrigerant called liquid nitrogen, which is good enough to cool these materials to keep them in superconducting. Liquid nitrogen is obtained from our air only because our air contains nitrogen and oxygen. So if you try to cool it using cryogenic technology, which is our main area, and I'm not going to bore you with that cryogenic engineering, which is a mechanical aspect, that we will talk some other day, maybe, how to produce low temperatures. Incidentally, the same Kamerlingh Onnes, who is a physicist, he was a very good mechanical engineer and he liquefied helium. He produced cryogenic liquid. And he was the only person in the world who is having the lowest temperature that time. And he utilized this liquid to cool various materials and try to understand what happens. And he got another breakthrough when mercury became superconducting. So a lucky fellow gets two gifts. One is he could liquefy almost like a permanent gas helium and produced cryogenic temperatures. Under those cryogenic temperatures, he could make a material superconducting. And it happened by an accident almost. He never knew that a material becomes superconductor. For that reason, any phenomena, first time whoever discovers, nobody knows, it almost happens like an accident. And he was so lucky that liquid that he has got is having the temperature of 4.2 Kelvin, and the material that becomes superconducting also at 4.2 K. So this is a great coincidence. If only the material that he took for his studies is superconducting at 2 Kelvin or anything, today we will not have superconductivity because he has got a liquid at 4.2 K and this material is not superconducting. So discovery would have missed it. But God will not do that. God will automatically give those people right arms to get certain materials. Yesterday's materials, that means yesterday's physics of materials, becomes today's technology. And when it enters into the market, tomorrow's engineering. This is true for metals. This is true for semiconductors. This is true for steel. This is true for biomaterials. This is true for polymers, everything. It starts from science, it becomes technology, and when it comes to public life, it becomes engineering. Why I am boring with you, to all of you with only one slide is once these ideas penetrate in your mind, these materials are exotic materials, and we physicists, why say we? Because the Department of Physics is organizing, and I'm sure a lot of physics students are listening to these things. Be proud of your physics community because it is the physics which makes all sorts of phenomena coming into existence, and they will be used in all technologies. Tomorrow we are going to have quantum computer. Again, physics, it is a quantum computer. Today we think that computers are very fast, but what we can do 1 year with this computer, a quantum computer will do in 1 minute. So what we think is the fastest thing, which is maybe 1 lakh times faster than our human calculator or how we calculate. Whereas quantum computer does 1 lakh times or even 10 lakh times faster than the existing computers. All this is possible because quantum mechanics and fundamental physics, solid state physics. So this I want you to understand. So when you look at the left side curve, when you plot resistance as a function of temperature, normal materials like copper, aluminum, etc., as you reduce the temperature, it becomes slowly resistance starts decreasing. That's called normal conductor. If it is a semiconductor, of course, resistance at absolute zero will be very high because all the carriers are frozen. There are no carriers at all to conduct, so it becomes insulator. Whereas in metal, carriers are fixed, free electrons are there in metals. Only their scattering mechanisms are reducing. So opposition for the flow of carriers is reducing as you reduce the temperature. So that's why conductivity improves, resistance increases. This all of you know. free electron theory, band theory, first year MSc people are teaching these things. But you must know why semiconductors increase, why normal conductors decrease. Because in semiconductors, as you reduce the temperature, they're also scattering to the electrons decreases. But carriers themselves decrease. Carriers are not there because conductivity sigma is Ne mu. Okay, so N itself is reducing as you decrease the temperature. That's why sigma reduces in semiconductor. Whereas in our superconductors, N is fixed more or less. Mu is very high. Mu increases in superconductivity state. So mobility, the ability to move for these electrons is so high that sigma becomes almost infinity. So you have to play with either N, best route is Hall effect type of measurements. E we cannot play because charge of the electron is fixed. That's what we thought. But in superconductor, that is also played. Later, Bodin Cooper Schiffer gave a theoretical understanding of the superconductor that it is not single electron, it is a double electron. So charge carriers in the superconductor, unlike copper, they are double Cooper pairs, unlike single electrons. So all sorts of exotic things happen only through the brain of a physicist and enter into the technology, either electrical engineering or mechanical engineering or civil engineering or electronics or communication or what, bioscience or anything. Without materials, nobody can do it. And it is the physicist who is at the base of all these things. Okay, I'm trying to boost the ego of our students because after 30, 40 years, they are going to be the leaders. And at that time, they will not do this type of laptops or this thing. They will do with superconducting quantum computers. So a bit of idea of superconductivity and appreciation is very much required for the next generation. And if you observe this slide, the Bodin Cooper Schiffer gave almost 40 years after the discovery of superconductor a theory. That is the beauty of physics. Sometimes theory comes first and the real application comes, real material comes out in a best way later. But in superconductor, it's the reverse. It was an accident. Superconductor material came first and the theory came 40 years. And both the people got Nobel Prize. The fellow who got by accident and the people who explained from the quantum mechanical principles. Both of them are awarded Nobel Prize. Because of that theoretical thing, further superconducting, still better materials are possible. That means one breeds the other. Theory breeds experiment, experiment breeds theory. That's why they are given Nobel Prizes. And as I told you, God gave us another gift in 1986, exactly after 75 years of its initial discovery. There was a high temperature superconductor by Bednorz and Muller, again an accident. They were almost like physical chemists. They were trying to do all sorts of materials. And suddenly, at a temperature which is unexpected by even theoreticians, theoretical physicists, suddenly became superconducting. In fact, today people are now saying that insulators are going to become superconductors very soon. A wooden piece also, sort of structures, ceramics, they may be superconductors. In fact, the name of these high TC superconductors are called ceramic superconductors. So our original idea that copper is a good conductor, rubber is a bad conductor, this is an insulator, all this is not there now. Everything is shattered now. Tomorrow, this rubber becomes superconducting, much 100 times better than copper. So that is called physics. So with this slide, we have understood a little bit of cryogenic engineering, cooling, and cross-sectional reduction, huge advantage to realize electrical power devices, and what is insulator, metal, superconductor, and discovery, theory, practice, everything. This is the introduction I wanted to give initially. This slide itself, we can talk another 2 hours also, but that's not the idea. So you got some idea about superconductivity. Okay, if that is okay, then you can go to the next slide. Now I will be a little faster because it is a routine stuff. Superconductors have got another beautiful aspect, not only resistance zero, it will expel all the magnetic flux from its interior body. That means it will not accept magnetic flux. It is a perfect diamagnet in the language of physicists who know better. I am trying to use physics jargon because I expect a lot of the audience, mostly 90% of the audience are physicists. So I don't have to know what is magnetic field. I don't have to explain electric field, free electron, etc. I assume that. So if you look at the magnetic aspects of it, it repels. Any material that is repelling can be used to float. So right side bottom, you will see a train that is getting levitated because of superconducting magnets and superconductors. A huge magnetic field is produced by a superconductor, and another superconductor which is there on the other side of it will try to repel it. That means the body which tries to repel the magnetic flux is actually used to produce the magnetic field. That is the beauty. That means if you try to take a superconducting wire and turn in the form of coils and make a solenoid, you will get a beautiful magnetic field that is being used in MRI or particle accelerators or even nuclear fusion or even levitation, etc. And even superconducting motors, superconducting generators, transformers, all devices. It is an electromagnetic application output of superconducting loops. But that loop material will not accept that magnetic field. That is the beauty. This is a like a philosopher. He will tell many things, but he himself is not interested in any of these worldly things. But he knows how to talk about various aspects in this world. So one should be detached. That is the beautiful example of superconductor. Superconductor is perfectly detached. It will not accept magnetic field its interior, but it will be the only material to produce highest magnetic fields on the earth. That is the beauty of nature. Hydrogen, for example. Hydrogen and oxygen is an extremely dangerous explosive. But hydrogen plus oxygen, when you mix, God mix it to produce water, which we drink. That is the peculiarity. If you can separate hydrogen and oxygen from water and then mix them as a form of gases and ignite them, that is called cryogenic rocket engines that is happening in ISRO. And that is the hydrogen bomb. That is how everything can be devastated. Huge amount of Shakti is there in that hydrogen and oxygen. And it can produce very, very high temperature flames. But same hydrogen and oxygen, God has made it in the form of water, which is used to stop the fire. Same thing in superconductor. So the right side, what you are seeing is an example of superconducting magnetic expulsion application. A train can be lifted because of this expulsive force. Because any expulsion will produce a repulsion force. A forces can be used to levitate. That's called magnetic levitation. Recently, there are other things called hyperloops coming, etc. In the vacuum environments with repulsions. All these technologies are used to make high speed, it's 500 kilometers per hour type of trains that is coming very soon. That is based on vacuum technology and also this repulsion technology and propulsion, etc. Which on some other day, if you are interested, I can explain because we are working on vacuum technology also. In fact, that was my main area also. I have written a book also in that. It will be my pleasure to talk on hyperloops, which are going to replace aeroplanes and everything in future. Anyway, right now in superconductivity game now, right side, just before we go to the next slide, I just want to mention that superconductor, how many times we are telling, but it is superconducting only if you cool it below a temperature called critical temperature. If you are heating it, it is normal. Similarly, if you applied magnetic field by somebody else, then also it becomes normal. Similarly, if you keep on passing current, assuming that there is no heating anyway, why not we pass 1000 ampere, 1 lakh ampere? No, at some current, it will again die. That means even the healthiest man, at some time, he will die. It's not that if you are perfectly healthy, you will not die. There is a limit for everything. Even for the world, someday it ends. The same thing, superconductors have got limitations called critical current, critical magnetic field, critical temperature. Within that limit, that is the surface that you are seeing in the right side top corner, within that limit HC, JC, TC, inside that surface, it is superconducting. Outside the surface, it is normal conductor. These are the basics of superconductivity, maybe already taught to you in your MSc, but if you necessary, we can again come and talk only on this slide 2-3 days. That's not a problem. Achha, am I audible? I just want to confirm now and then. Hello, am I audible?
Yeah, you are audible.
Okay, slides are visible.
Yeah.
Okay, now next slide, please. Okay, these are the 4 applications which I have already discussed a little bit, and you can see that left side, that is the application of superconducting magnet in, I don't have to tell you, MRI, and that is in a hospital room, and the patient is going through that. And what is MRI? If you want, one full day, some other day, because there are lots of bio people also involved in this. And bio, what is happening? Our body is full of protons, and that H plus protons have got magnetic moment, and these magnetic moments are aligned to very strong magnets. And if you put a RF radiation and parallel to that, it will be excited, and switch off that RF radiation, it will start relaxing very fast, aligning to the magnetic field. The time how it falls back, that resonance in a magnetic field, that means magnetic resonance, that time constants can be utilized to get the information about the field of that hydrogen molecule, that hydrogen atom, that are proton that is there in our body. And if you make all those calculations properly and compare it with a healthy body or a sick body, we can image it through Fourier transform and various other routes. And if you make magnet from superconductivity, a resonance from RF, that is a quantum mechanical absorption phenomena, and then eye imaging from the modern electronics and mathematical technologies like Fourier transform, we will have an MRI. So many technologies together are coming back into biotech, biomedical engineering, and in a medical technology. See how the technology is passing through various types in a public society, because technology knows how to enter into the society. We cannot stop. Just like computers, 20 years back, they stopped in the banks. There is strike also. But today, without computer, nothing works. So technology will automatically go into public. After 20, 30 years, you will see entire technology, all the computers are superconducting computers, all the carriers that are there in our house, copper wiring and magnets, motors, transformers, everything will be superconducting. All the vehicles that will be traveling will be superconducting. So everything will be superconducting. Only thing is, we'll have to maintain them properly. We have to understand them. So there is a lot of technology that will take its own time. Next generation will successfully do it. So that is called left side MRI. Right side, that is the future energy storage called nuclear fusion magnet, right side top, which is being built by 7 countries together. India is one of them. This is called ITER, International Thermonuclear Experimental Reactor, nuclear fusion. That is exactly going on in sun. That is, one deuterium and tritium molecules are continuously mixing to produce helium atom plus 1 neutron plus high amount of energy, and that energy is coming to us as a sunlight to us, and only fraction, even billionth of a fraction that is coming to us, we are feeling sweat, so much hot. You can imagine what is the temperature of the sun. That billions of degrees of centigrade is responsible for this reaction, where the nucleons overcoming their plus to plus, because both are nucleons, both are protons, but still they overcome their Coulombic forces and join to form a helium particle. This beauty we have to simulate on Earth. That's called nuclear fusion, and it is highly non-dangerous, unlike nuclear fission, which is a radioactive. So throughout the world, people are working on this nuclear fusion, but it is possible because of superconducting magnets. So this is another application of superconducting magnets, storing huge amount of energy in a very limited volumes, where this nuclear fusion of lighter particles are getting into that, and the binding energy gets released, and that is enormous amount. So Tirupati will have a mini sun in the night time in the body in a SV university. So every city will have their own sun. We don't need to have suns. This is another thing. So very soon it is going to come, if not now, another 30, 40 years. So our hospitals, our energy sources, our transport, our computers, our cell phones, and our electrical equipment, motors, generators, every transformers, transmission lines, everything will be superconducting. And if you can transmit electricity with superconductor, there is no loss, I square R. In India, 400 gigawatts of power is being produced in 2020. That is the estimated thing. Out of which 50 gigawatts of power is lost as an I square R. So huge amount of loss we are having. If only we'll have a superconducting wire instead of these aluminum wires, etc., 50 gigawatts will be extra available to the public. So very soon that is going to come. We are working on that along with Power Grid Corporation. IIT Kharagpur is working on that, and the Central Power Research Institute is involved. All these things is possible because the basic fundamentals of physics, which I have learned from SV University Physics Department. Okay. Now, coming back to the left side, we are having, this is a typical scene when we are traveling in the train. There is overhead lines, high voltage lines with a danger symbol. Green land is being wasted. No crop is there. Left side. Now, the entire thing can be disappearing if superconducting technology is used, because in the bottom, in the ground, you will see underground, there is a superconducting only 3-inch diameter line, the small pipe of our crowbar type of thing, which will carry the same power which these big things of 200 meters wide, your network is carrying. So immediately thousands of acres of green land across thousands of kilometers of India will become free if only transmission is going on. Again, the beauty goes to R is equal to 0 concept of superconductor. Again, I am not yet come to the energy storage, but I am talking superconductivity because it is interesting. Similarly, right side, all the blocks, multi-stored blocks, so that copper wires are there. They will be replaced with one superconducting wire to supply the same power. So these are various applications of superconductivity. That means you can generate electricity. For that, a 500 megawatt type generators, which BHEL makes, is of the order of one building or your department size. If you use superconductor, it will become your room size. Similarly, the transmission that is going on a overflight at 1400 kilovolt type thing. Now with superconductors, you can put 40 kilovolts, much lower voltage, high current. And similarly, transformers, motors, everything is going to be superconducting. Next slide, please. Okay, next slide. Yeah, so you will see transformer size has gone down. Conventional transformers right now we are using just outside your building, it is there. If you use superconductor, it will be reduced to 1/4. Similarly, motor, big motors which are there in industry, that will be reduced to a smaller size if you use superconductor. Similarly, the wires, large scale, very large scale industrial wires, copper, is going to be reduced with superconductor. It's not only the reduction of the size, it also reduces the loss. That means 10% of our energy that is being lost, that will not be lost if you are using superconductor. So that way, it is related to energy sector, whether it is energy storage or energy loss, both are same. Energy saved is energy produced. Okay, again, back slide, please. One slide back. Now, now I am slowly coming to energy storage. I think time is up also, so I have to be a little fast. That is my problem. Anyway, I cannot stop. So because physics is physics, I like physics more than application. So I like to talk like that because it's a physics department. So before I enter into superconducting energy storage, just want to pass by remark that the superconductor is also extremely useful in other applications. And some other day we'll discuss. That is called superconducting computers, superconducting quantum interference devices, and these are all possible because of a peculiar phenomena called tunneling. Tunneling also is explained in our quantum mechanics. That means if there is an insulator that is sandwiched between two superconductors, the insulator suddenly becomes superconductor. It is like one bad boy in the vicinity of very two good boys, suddenly he'll start becoming good boy. It is exactly like that. That means we are making the insulator to behave like a superconductor. That means the Cooper pairs are maintaining their coherence, and from the left side superconductor to right side superconductor, they are able to tunnel without any dissipation. This is what is discovered by a young boy, Josephson, when he was doing PhD. And Josephson, under his supervisor, the topic of his PhD is something else. But guide said, if you want, you do whatever you like, but you do this for PhD. And he did PhD in some other materials, but he also did his own thing, one-page paper that possible tunneling of superconducting Cooper pairs through an insulator, for which he got the Nobel Prize as a student discovery. I'm sure our MSc girls, because the Mahila University, Mahila Shakti, very good. If you are strongly related to quantum mechanics, advanced quantum computing, I am telling you, within 10-15 years, there can be one Nobel Prize from you. And we will be proud of you. Okay. So this is called superconducting quantum devices. Slightly raise it, the same slide. No, rise, the other side. No, not down maybe. No, earlier slide. Yes. Still. Okay. So right side, what you are seeing is going to be an advanced thing for which superconductivity is going to play havoc, very important role in cryogenics. This is called quantum computer. After 10 years, all the computers that we are going to use will not be there. SV University will definitely purchase this computer because that will be 1,000,000,000 times faster than the best possible computer that your university has got. This is possible because of superconductivity and quantum mechanics and low temperature physics. And left side, Bharat Heavy Electricals Limited of our Hyderabad is making a superconducting motor with our collaboration, and that is the signal. That means, in one word, what we can say that green thing.
She's texting you. Oh my God.
Hello, superconductors are going to replace all electrical conductors like copper and aluminum in electrical engineering department. And they are going to replace the two stalwart electronic materials called silicon and germanium in electronics department and computer department. Imagine the power of superconductivity. All the conductors in the electrical engineering domain, BHL, Crompton Greaves, Schneider, and all electrical companies will be working with replacing copper with the superconductor. The power of power sector will be based on superconductor. And the next power, that is computing power, is based on superconducting quantum devices. So this is the most modern world, which is based on two things. One is energy we require. We also require computers. These two are going to be totally controlled by superconductor. That means superconductor is going to replace semiconductors. They will win over the semiconductor. They will defeat semiconductors to produce quantum computers. They will defeat copper, which is the best known conductor, even gold, to become superconducting better than them and replace all of them in electrical engineering. With this introduction of superconductivity and application, next slide, please. Yeah, this we already discussed. Next. Now, I think I should go to superconducting energy storage. I think already I've taken 50% of the time. I'm sure it may be boring also, but but introduction is very important, because if you understand this superconductivity from the physics point of view, that is more important, because in any way, none of us can make all these applications in our lifetime, because that requires engineers, lots of technologies, industries. What we can certainly make is to make these materials and suggest the engineers to use these materials. That's why I spent a lot of time on superconducting materials, but though the topic is called energy storage. Now coming back to the energy storage. Are you listening?
Yes, sir.
Is it clear?
Yes, sir. Yes, sir.
Okay. Now in Tirupati city, you are getting power. This is SMES, energy storage. Now we are in the real topic, energy storage. How much, who is supplying power to Tirupati? Somewhere, somebody is making, definitely. I call power, I don't call energy. Is it not? Because electrical engineers always they call power, whereas physics people call energy, because their time derivative of energy is power. Energy, when it flows, that means rate of energy is called power. All of us know very well. This is taught in 10th class also. But today we are talking energy, not for the sake of energy. We are talking of energy storage, because power can be supplied uninterrupted power supply. घर में current जाएगा तो what we will tell? Power cut. We will never say energy cut. Why? Because energy is there always. Energy, only when energy is there, power is there. But energy is there without power also. But power cannot be there unless there is energy. If there is a reservoir of water, we know how to distribute that to various houses with a high pressure. But reverse is not true. We need energy. That reservoir of water outside the city is called energy storage. Whereas water coming into our pipes everywhere and overhead tanks, that is like equivalent to power. Okay, flow of water. So flow of energy. No. Anyway, this three-phase line is called the generator. Slightly rise. That's correct. That load is Tirupati. The three-phase line is the generator that is supplying power to Tirupati. Now, sometimes all of us are so good, we'll switch off all the things and there is something going on, some maybe in Tirupati, there is near the temple, there is a big thing going on. So all of us go there. Everybody switches off lights, fans, TVs, everything. But this generator does not know. It continuously supplies same power. How can it supply? Load does not want. And suddenly all of them come back to all the houses and they want huge power now. At that time also this generator cannot supply because the supply, load, demand, they never follow each other. That is, of course, there in commercial terms. Commerce people know better than us. Fund availability and fund flow. These are budgeting and all. They have to know that supply chain management. Okay, same thing here also. The supply of power and the utility of power, they cannot be exactly equal. So if you have producing more energy than what is required by the load, by the Tirupati people, this much is energy required for every second in the form of power. But the energy generator is producing more power, let us say. What to do? That extra energy, it has to store somewhere. Because if it gives done, they will not accept it. So what they do is part of the three lines here connected through a transformer, through an AC to DC converter to a superconducting coil, having its own cold box, because unless you put them in the cold conditions, it will not be superconducting. So that is associated with a refrigeration system, and all of it is being controlled by a control system. So this whole figure shows 5 blocks. That is generator. The load is our fans, lines, motors, freeze, TV, all sorts of things. The lakhs of houses in the Tirupati, that is called the load. And superconducting coil, somewhere standing outside of the Tirupati city, being cooled by the cryogenic temperatures. And that is also receiving this power. But that fellow, unlike us, it will not waste that power. It will store that power. In fact, I should not say power storage, but it's okay. Current, power, these are all synonymous. But actually we are storing energy. We don't store power. Okay. So though we can say power storage and all, but actually energy storage. When you are discharging it or charging it, then power comes during the dynamic conditions. But always static conditions, it is the thing. It is like, the money is the energy, but salary, every month that you are getting that money, that is like a power. The same thing here. But when you are having more money than what we need in our house, what we'll do? We'll put extra money in the bank. But some other day when we fall sick, when suddenly some corona attacks or something, we require much more money than our salary. At that time, what we do? We add that stored energy to our salary and use it. And again, when corona is down, we'll again start storing it. So this storage is a concept that all of us know in our day-to-day life with respect to finance. Whatever happens to finance, energy also same. If there is a financial audit, there is an energy audit. For your information, every year Government of India recruits hundreds of energy auditors. And today, a lot of financial people who are chartered accountants, they also do energy auditing. So when financial auditing requires financial storage in banks, why not energy auditing requires energy storage? This should be viewed like that. And it is possible only because of superconductors. Because any other coil, It stores, a coil stores half L square, no doubt, energy storage, but it also dissipates I square R. The moment you stop flowing the energy inside, immediately whatever stored energy is lost as a dissipation. So you cannot store it. You can store only when there is no loss. So that's why superconductor is the only way if you want to store energy in terms of current. Battery, how it is stored, that we will see later. What are the various types of energy storage, electrical energy storages? Battery, flywheel, superconducting inductor, capacitor. These are the four ways. That's the only way to store energy. Okay, let us come back to that next step. So this slide says that a generator supplying power to a city also supplies extra power to the superconducting coil, coolly sitting with a continuous refrigeration cooling unit. The extra energy is so high that the refrigeration cost is negligible. So you don't care about that small energy that goes into that. Whereas the excess energy that any time is available. If there is a problem with three-phase line now, that means the generator is tripped for some reason. Today there is a tufan in Tirupati, so then everything is stripped off. Now the energy that is there in the superconducting coil, earlier it went from left to right, the power flow was left to right, AC to DC converter. Now right to left it will come back, DC to AC. Transformer also right to left, and it will come back and then come down to the load. That means three-phase line is now sick. It is not working now. It is a tufan. The generator is switched off, power cut. But half L square stored energy superconducting coil immediately comes into the load. Load fellow does not understand. It is like our inverter. As soon as power cut is there, immediately inverter comes. If it is generator, we have to go and switch on something and all. But inverter is automatic. Power electronic circuits will make it automatically. But where that energy is coming till that time, earlier when our power is good, it has stored in the form of a electrochemical energy in a battery. That battery will again store it to a capacitor, and that will be inverted properly, and through a transformer it will be exactly matching to our 220 volts. Within millisecond all these conversions are going on. This called inversions, and we'll get the same current. We don't know whether energy is coming from the battery or energy coming from the main grid. So such a powerful power electronics has been coming now. That's why these control systems are very good. Electrical engineers do very well. Power systems, power electronics, control systems, they know very well. And all of it is basically a physics. All the electrical engineering is 12th class physics. All the mechanical engineering is 11th class physics. If you want, you can relate easily. Okay. Now, this is called energy storage principle using superconducting coil. Now here energy is stored as what? Half Li square. Why superconductor? Because I square R is not there. Why half Li square? Because I can be very high. Thousands of amperes of current can go and without any loss, and persistent currents. They will persist without any additional energy once you store. So very good, everything. It's like bank, no? Fixed deposit. You store it, that's all. But it's fixed deposit. It has got flexibility. If you want, you can break it anytime. That's called superconducting coil. Next slide, please. Yeah, this is a boring table. Well, all of you know. Slightly raise this table. That's it. That's it. These are various methods of storing energy. Right now, what is happening in our data centers? If there is a power cut, they will run out. No, very expensive data. If there is a problem with the data, all our accounts overnight, your fixed deposit 10 lakhs will become 10 rupees. Very dangerous because manual operations are not much. So data centers are now powered by what? Batteries. But lead acid batteries, sodium sulfide batteries. That is also energy storage. There is huge amount of research going on, even in our IITs also, and very good research. But there is a but. This is electrochemical energy storage. Yes, very good. Used batteries, where will you throw out? Environment people will come and sue you. You cannot throw your battery just like that in the dustbin. People will again just throw it back into your house because it contains lead, which is poisonous. So, though electrochemical batteries are very good, compact, and it does not require cryogenic engineering, it does not look like all this high-tech superconducting jing-jang. But It is dangerous. Once its life is over, you don't know how to discard it. You have to throw somewhere. This wastage is very important. Nuclear waste, similarly, this electrochemical waste is a big problem. Environmental engineers are coming in a big way. Once upon a time, environmental people are not there. You do whatever you like, you throw anywhere, whatever garbage you want. The people are throwing huge amount of garbage from the industry into rivers. Today, it's not allowed. You cannot throw the smoke. Delhi city, what is happening now? You smoke, empty everything, oxygen levels are going down. You cannot do that. Environment is going to play. So electrochemical energy, that is lead acid battery, which is very good, but it has got space requirement very low, very good about it. But its lifetime is limited. Number of cycles is limited. After 1 year, 2 years, you have to mercilessly throw it out. And cycle duration is also not much. And efficiency is also not much, 50 to 70%. Why? Originally, electrical energy is converted into batteries as electrochemical energy during charging of the battery. There is a conversion of electrical energy into chemical energy. Now that chemical energy, when we want, is coming back as electrical energy. That means there is a double conversion. So first conversion, if there is a 70%, and 70% of that 70%, that is 49%, we will get only 50% back. So don't think that we are storing energy when we are healthy. No, there is something. It's like current account. They will not give interest at all. This is like that. So here we are storing. We think when we are having beautiful electricity coming from the state electricity board, we are storing some of the energy into the batteries in our inverters. Fine. But only 50% of the energy is kindly converted as electrochemical energy when it comes back to us in the power cut situation. So that is called efficiency. Cost is, of course, medium cost. But maximum power out of energy, this is another point which physicists should know. A small battery that is available in the market in the Gandhi Bazaar, if you bring it, 1.5 volt or 2 such cells in our battery light, it has got 1 megajoule energy. I'm telling you, you calculate. 2 batteries together has got roughly 1 megajoule of energy stored in that. That little motors, little thick batteries, torchlight batteries. But 1 megajoule means, can you draw 1 megawatt for 1 second? 1 megawatt into second is called 1 megajoule. So it should be possible to give power to the entire campus for 1 second out of 2 batteries. Can we do it? We cannot do it. That means even if we have 1 megajoule energy, we can only make 6 watt bulb to go for 100 hours, 2 months in a torchlight. We cannot make 6 megawatt, or we cannot make 1 megawatt per second. But when you do superconducting energy storage, same 1 megajoule energy, if you want, you take 1 megawatt for 1 second, or you take 1 watt for megaseconds. It is possible. That is a very flexible account. If you want total money withdraw, or you take 100, monthly installments also you will get. Such schemes are there in various banks. So same thing here. That flexibility is not there in battery. You cannot draw huge power. Battery will burn, it will immediately catch fire. Because why? Internal resistance is there. Thevenin will not allow us to transfer maximum power. Because internal resistance, drop voltage will be there. As soon as short circuit to draw more power, the voltage will drop to 0. That's the problem with batteries. Okay, but then what to do? How electrical engineers, generator people are storing? This is a small scale in our day-to-day life. Okay, computers, batteries, temporarily we are solving it. But this is a nuisance after some time. So this nuisance we have to overcome by another new sense, that is NEW sense now. How? That is called superconducting energy storage. Okay. In between, there was a pumped hydro storage, which is now being followed by all the electrical engineering stations, substations, etc. Are you listening?
Yeah, yeah, we are.
Okay.
Audible.
Okay. Okay. Audible. Okay. Audibility is different and listening is different. Okay. Fine.
Yeah. First,
Yeah. So mechanical pumped hydro storage means when the generator is running very efficiently, but all the energy is not required by the customers, what they do is they use this water pumping to the hill stations and then store it in the form of a water. And when energy store requirement is much more, we'll get back that water again back like a hydro power station. We'll mix it with our thermal power station. This is the management going on in India and various countries. This is called pumped hydro storage in the large grid scale. Small scale for data centers, we require data energy storage batteries. But large scale electrical power equipment, people require energy storage in the form of pumped hydro storage. But physicists very well know where is this energy coming. In pumped hydro storage, it is rho g H. In lead acid batteries, it is electrochemical energy. You can also store it in the form of flywheel, and that is called half I omega square. That is all these things are taught in 11th class. But what is not taught in 11th class or 12th class is superconducting energy. That is taught in BSc and MSc maximum. The superconducting materials are quantum effects. Quantum mechanics, superconductivity, everything is taught only in MSc. Now come to the last line, superconducting magnetic energy storage. If you compare this energy storage with respect to other energy storage technologies, it has got 95% of the efficiency, which is very good. Why it is 95%? Because we are storing electrical energy as electrical energy. Because half Li square is also electrical energy. There is no conversion of electrical energy into a mechanical or chemical or a gravitational or a pumped hydro or etc. If you are converting one form of energy to the other energy, then there is a loss, conversion loss, that is called. Okay. In the utility, if there is a loss, that is called utilization called, that is called dissipation loss. Conversion loss, dissipation loss, all these losses are there in electrical sector. People know very well. And physicists also know very well. Loss factor in a dielectric, for example, tal delta, epsilon dash, epsilon double dash. This also is known. Loss we don't want. Advanced dielectrics that are being used in superconducting quantum computers, etc., they require very good capacitors, not only batteries. Why? What they will do? Because it is the capacitors that are going to play havoc in computers. Okay. So like that, superconducting magnets here, when you store the energy, energy is electrical energy storage. So no problem. From the electrical to electromagnetic, again electromagnetic back to electrical. No problem. Electromagnetic is as good as electrical. So it's magnetic energy storage means it is basically electrical. In fact, electrical engineers, 50% of their BTech program, they do only magnetism. That's why electricity and magnetism is together offered as a course in our BSc. Because these are interrelated, electromagnetic theory. Okay, electrical and magnetic fields are interrelated. You cannot separate them. Okay. Anyway, I'm not going into the depth of it, just to make a fun of it. Okay, next slide, please. So I told you very, very large scale superconducting energy storages can be used to make the load level variations of the whole city. Power cut, voltage problem will not be there. Voltage drop should not be there. Such major problems, SMES can be there. Similarly, medium scale is small fluctuations in the stabilization of power grid, which is not our headache, but the fellows which are there in the substations in the Renugunta and many substations here and there in the cities. And substation means you know very well. And no, this is a up converter, down converter in electrical in sectors. Electrical engineers know very well. The generators are at 20 kV, produce the electricity, and they are up converted to 500 kV in the transmission line. Why up conversion? Because loss is less. Because R, I square R, I will be for the same power. Power is V into I. So what they do is 20 kilovolts, they up convert to 400 kV. I will be reduced in the transformer. I1 V1 is equal to I2 V2. So that up converter, what they do is they up the voltage and reduce the current. Because through the transmission line, which is coming from the Renugunta to Tirupati, the transmission line, we are not using that power. If we are sending it at the 20 kV, current will be more. That I square R will be dissipating to the air. Air will be heated up. We don't want that. We want energy all the way to come to SV University. In the Rasta, there should not be losses. So transmission losses are not allowed. That's why it is high energy. High voltage, their transmission, But when it comes back to us, we again reduce the voltage through various transformers. There is a transformer opposite to our house also. Finally, we want it in 220 volts. So there is a transmission transformers, distribution transformers. Distributions are under the purview of state governments. That's called DISCO. And transmission is TRANSCO. So transmission is a national power grid, whereas distribution companies are state government. Why I'm talking all these things are, a physicist should know where his free electron theory, where his band theory, where his semiconductors, where his metals, aluminiums, and dielectrics, and epsilon dash, where all this going on. Which electronic engineer, which communication engineer, which electrical engineer, which mechanical engineer, what they are doing. If you know that, then why not you enter into those jobs? You must be able to get same job with MSc Physics. What a advanced engineer with a lot of knowledge will get. Why not? Energy is one such field, I'm telling you. Energy storage, energy, alternative renewable energy, solar energy. It is coming in up a big way through the called physics converted into material science, and of course through the engineering metallurgically through large scale, and finally enters into electrical engineering when it comes to the making of fans, lines, motors, transformers, etc. But as a physicist, you should know all of them. Then only, if you know the entire thing, then only you will become great physicist. Einstein definitely knows when he makes E is equal to mc square. He definitely knows what does he mean by that. Bomb, etc. He knows very well. Similarly, Maxwell very well knows electromagnetic theory. Then immediately he knows that this is going to be used one day by all these telecommunication engineers. Electronics engineers will get better jobs in telecommunications. So EC has become a BTech only last 30 years because of Maxwell. So all the physicists should know where they are applied. So in the very small scale, energy storage is used in our day-to-day life in our small scale. But this is not cost effective, because how can we have various convenient ways of cooling, etc.? Not possible. But in a large scale and medium scale, cooling is not a problem, because cooling takes only 1% of the energy. That doesn't mean there will be dedicated cryogenic center will be there, and some mechanical engineers will be running that refrigeration and cooling these materials so that they become superconductors. And we only electrical conductors start using, electrical engineers start making motors. And the gain that we are getting is in gigawatt hours, and the loss that we are getting is only megawatt hours of energy. When I say energy, it should be megawatt hour. If you say power, it's only megawatt. One should be very careful. Okay, 1 kilowatt hour is called 1 unit that we are talking in our day-to-day, 100 units of electricity like that, 1 kilowatt hour. Anyway, next slide, please. Because when you are talking energy storage, no point in only talking energy storage. We must know the units properly. We must know the differences between energy and power. We must know the losses. We must know the material properties which are responsible for these losses, and how to overcome that, and how to draw these materials in the form of long wires so that they compete with the copper wires, so that they are also malleable, ductile. Metallurgy, which is the advanced material science, which is again advanced physics. All these things are important before it enters into electrical and mechanical engineering. So we must know all these things in a nutshell. Something about everything is very important, just like everything about something. So physicists, when you should concentrate in your learning, how to understand these materials and quickly go to applications. Well, you may say, sir, how do I know all these things in my life? Time is not there. No, you have enough time, because you don't have to depend. There need not be coaching in that in your university. Google is the university, Google University. Just Wikipedia, you go there, whatever I'm talking, you will get much better resources there. You will understand everything in the world just at the stroke of a hand. Immediately you can understand energy storage means what, etc. You please go through all those things in Wikipedia. Hundreds of reports are there in energy storage, in batteries, energy storage in pumped hydro, energy storage in capacitors, energy storage in this one. But as a physicist, you should know that is half I omega square. This is half Li square. That is electrochemical energy. And then if it is capacitor, it is half CV square. Since voltage is very high, we will not normally store energy in capacitors. Very peculiar applications in war field, etc. They may use half CV square to suddenly fire some missiles, etc., etc. But day-to-day life, we will not store energy in the capacitors. You know reason?
Because if you want to store, you have to increase the voltage. Voltages are very dangerous. Same energy, if you are increasing current, no danger. 1 lakh ampere, 1 volt, same power. You can touch with your hand, no shock will come. But 1 ampere, 1 lakh volt, same power. If you touch, you will get shock. Because high voltages are dangerous. High currents are not danger. That's what in the first stroke. But second point, in the second level, high currents are also dangerous when if you bend the conductor to produce magnetic field, they are dangerous. High magnetic fields are very dangerous again. Dangerous means you have to handle them properly. Enormous forces are there. You will not get electrical shock, but there will be forces which can hit you, magnets. So you have to look. And so superconducting magnetic energy storage, why I am introducing these forces, etc. right now is half L square energy storage. Everybody says, okay, that is 12th class stuff. Why MSc people have to learn? But MSc people have to learn that you have to make ampere turns and to make a coil so that L is more. And since it is superconducting, I is more. So half L square is very high. But whether you should make L more or I more, who will tell? An electrical engineer having huge amount of physics background, they can design. They are highly paid staff, highly paid people. So a physicist, he understands the electrical aspects, can get huge payment because he is going to design a new structure. So these solenoids are made in Japan, very smallest country in the world, and very largest country in the USA. We are in between. When Japan can make 5,000 megawatt hour stored energy, first row you see, 5,000 megawatt hours SMES is there, superconducting magnetic energy storage. USA is making 5,500 megawatt hour. That means a Tokyo city can get 10 one day power. A Tirupati city can get almost 1 week full power from a coil which is just located, whether there is a thunderstorm or not. 1 full week you will get full power, all the houses. 5,000 megawatt hour. No, see in house how much we are using? Kilowatts. Okay, kilowatts into 24 hours. So maximum 24 kilowatt hours or maybe 200 kilowatt hours. And then even 1 lakh houses, even if you make, it will be like this. 5,000 megawatt hours is good enough. Maybe 5-6 hours or 1 day you will get all the houses. This sort of coils are being used. It is possible because 100 years back superconductivity was discovered by a physicist, and 30 years back another fellow discovered, and then refrigeration is also discovered by physics people only. The Joule-Thomson expansion is the reason. Joule is a physicist. Thomson is a physicist. Okay, everybody, even the electrical motor generator is discovered by whom?
Hello. Hello, sir. Hello. Hello, sir. Your voice is not audible, sir.
Hello? Hello? అయిపోయిందా?
పవర్ కట్ అయ్యండి సార్, ఫోన్ చేయండి కృష్ణయ్య సార్.
అదే ఫోన్ కట్ అవుతా ఉంది సార్.
ఫోన్ చేయండి ఒకవేళ పవర్ కట్ అయ్యండొచ్చు.
అవును, ఓకే ఓకే. అక్కడ పవర్ కట్ అయింది సార్. జయశంకర్ సార్ ఫోన్ చేసి.
హలో హలో
Hello. Hello.
ఎవరితో మాట్లాడాలి?
ఓకే ఓకే సార్. ఐ థింక్ Net from I expected actually. Okay, okay. I think.
Hello, sir.
Yeah, please. Okay, sir. Thank you. Right, sir. We can. Hello. Hello.
చెప్పండి సార్.
Hello.
Disconnect
Jayasankar.
అయిపోయింది.
Another 10-15 minutes. He will complete.
Am I audible?
Yes, yes.
Yeah, yeah, yeah.
Okay. It
So,
is
Please go.
again, net problem.
Oh, yeah, we understand.
Earlier, we used to think that power cut is the nuisance. Now, net cut is also nuisance. Net is, we are netizens. We are no more citizens. And we are not doing, we cannot give seminars. We have to give webinars. So, world is now controlled by net.
Net.
So, what to do?
Okay.
So,
Okay.
next slide, please.
Next
I'll be
slide.
faster a little bit.
Okay.
Fast.
Yeah.
Next slide. Yeah. So the technology is like that. This figure shows right side a trolley. This is not a imaginary fiction. It is a photograph of that actually. There is a trolley having liquid helium and transformers, superconducting coil, everything in a trolley. Left side there is a laboratory which is being totally powered by the stored energy from the superconducting coil, half LA square. You may say, sir, why these fellows are keeping their computers, lights, fans and all from a half LA square energy stored outside like a petrol tanker? Why? Because they are in a war field. They are not comfortably sitting in a university guest house or a quarter in IIT. They are in war field. So in war field, there is no electrical line coming from the outside. If you put the electrical line, enemies will know immediately and bomb it. Okay. So this is a Air Force base basically in a war field. So they will be giving signals to bomb various things, to various radars, various things. And these are supercomputers being powered by these things. And there should not be even 1 millisecond flicker on that. So this is called superconducting magnetic energy storage for high-tech applications. Here the amount of energy storage is not much. It is not like one city energy that is being supplied by a half LA square staying outside when there is a power grid problem. It's not that, but its value is much more because it's a data centers. Our data is much more valuable than energy now. You can stay without even electricity. You can stay without food. Nowadays, children cannot stay without cell phone because data is more important. That's the reason, because electronics is now dominating like anything. Okay, so this is one example where superconducting magnetic energy storage is used not as an emergency measure, as a routine measure, because they don't want to believe power lines, because anytime anything can happen. So when, see, we are normal people, so net problem, again problem like that. But see, when very big shot gives anybody lectures, when some national leader or something, people have to be extremely careful because 2 minutes cut, then nobody can listen. So we have to make against any problem. So that's why in war field, they don't take any risk. This is called one example of energy storage in war field. Next slide, please. So based on all these things, Government of India also has given us a project at IIT Kharagpur. This is the magnet, left side superconducting magnet, which we have made in our house, in our lab, sorry, in IIT, along with Bharat Heavy Electricals Limited. They have helped us. This is a beautiful collaboration example between IIT and BHL. And now they are willing to do for various industries and universities, etc. So we can do something together also with SU University if we can work out properly, particularly with Padmavati Mahila University. We can start something. We can write some mini projects because DST gives a lot of money, CPRA gives a lot of money. many people are willing to give money even at materials level, even in the small lab scale level, even in the simulations level, even in the theoretical level. So right side, what we have done was, it was done 30 years back in our lab. We have switched off the mains in our small, dirty looking one small laboratory, and all the lights and fans are on. From the magnetic energy half L square stored in a cryostat, the stainless steel structure is there right side, which is kept on the underground type thing. Half is underground, half is above the ground. That because of conveniences. And also magnet should be below, because huge magnetic field, magnetic flux leakages out. If there is a pacemaker, it will go into asynchronous mode. And if magnetic fields, if there is a small needle or something, it will go and hit. And if somebody else is there, it will pierce through the body. So high magnetic fields are very dangerous. That's why in MRI, etc., before you enter into the hall, people will say there should not be even one small pin on your shirt. Any magnetic material, you are in trouble. It will be like it will be just needling your body. So one has to be extremely careful in magnetic fields. This is what we have done in SMES development at IIT Kharagpur. This was the first SMES made in India. And I feel very satisfied, because this was the project where I have handled first time as a investigator, along with electrical process and along with an industry. That was the satisfaction. Similar thing you can do in batteries also in universities, because there is a huge demand for high quality, very high compact batteries. This magnet that you are seeing in the left side is a small thing. It's only 1 foot by 1 foot type thing, but it produces 5 Tesla magnetic field. If you want to produce 5 Tesla magnetic field with a copper wire, it will be more than your auditorium size. Normal magnets that we are seeing in our Hall effect experiment, etc., is how much? 1000 Gauss Hall effect experiment in a physics laboratory. This is not called 5 Tesla, 50,000 Gauss. So that is the volumetric ratio that you can see with the SMES, energy superconducting magnetic energy storage. There is a permanent magnets also store a lot of energy. That's what I think it will be discussed in the afternoon, maybe by the other speaker. That is permanent magnet, solid state magnet type of materials. There are energy storage by dielectrics also. So there is a lot of things working on battery materials. So varieties of things varieties of people are working. And my lecture is on conductors, superconductors, basically. Next slide, please. So in power application, I have already told, you can read out these things also. The energy storage is very important in power grids, because unless you store the peak demand, the only generators cannot apply. By chance, there are 100 of marriages going on at the same time in Tirupati. All of them are switching on a huge amount of generators and bulbs, and the power supply cannot be coming from there. Then what to do? So, but if there is a stored energy, that will be added to that. In fact, that's what we are doing by generators and batteries. But in if electrical grid level itself, if they can store properly, and if there is a communication protocol, if you inform them, they will immediately discharge the energy stored from the superconducting coils to the marriage pendal. So this sort of thing, very soon, huge energy management is going to come. All the INs are being they are teaching this course, energy management and energy auditing. These are all very important. Unless you do all these techno-commercial aspects and materials aspects, technology will never come up in this country. Okay, so we have to understand how to do this for power grid application. Next slide, please. We are coming to the end. So when there is a huge fluctuation, when there is a short circuit, because whenever there is a grid, see, power need is different. Power grid is bad. We will switch on all the lights, all the fans, everything, even though all of us are sitting near to the TV. We will forget. Almost 1.5 kilowatt of power is going on, but we are watching only 100 watt of TV and another 100 watt of fan and light. But another 800 watt is being wasted in kitchen and everywhere. But we don't care. If every house does that, then there will be short circuiting in the grid stack. That means there is called failure. That's called fault. If there is a fault, or if this rainy season, thunderstorm today right now is going on, somewhere the three-phase line will be shorted. The short circuit will be there. Transformers will burn. At that time, what will happen? Voltage will fall down from 220 volt to 20 volt. Power also will suddenly come down. But generators don't understand that. Generators keeps on generating. So there will be a lot of problems. After some time, generators also will fail. That's called power grid failure. Long back, we used to hear that grid failure. But today, because of power electronics and energy storage technologies, these are mitigated properly. And that's how we are not running risk of these grid failures anymore. But in spite of that, even now, because of natural calamities like Tufan, etc., there can be a lot of grid failures. So here what you are seeing is whenever there is a short circuit, which is associated phenomena with any power system, like power grid, etc., maintenance in substations, etc., there will be a lot of oscillations in the power flow, which is very bad. If those oscillations are coming all the way in the smaller scale to our house, your dimming light will be there. Okay, your light is dim, no problem. But if your fridge, if there is a voltage fluctuation, motor is burnt. Similarly, if there is a very sophisticated computer is gone. Next day you will be weeping. Your fridge is not working, your computer is not working, your TV is not working. Only bulb will work. What is the use of that? So with SMES, if it is coupled by the generator fellow, you will see the other line, which is a steep line. Even though there is a fault, once fault is cleared, immediately the stability of the power system has increased. So this apparent power stability utilization using superconducting magnets made out of superconducting materials developed by the material scientists with the backing of physics, with the discovery of superconductivity, is responsible for smart grid. Earlier it used to be called power grid. Today it's called smart grid. Smart materials. Sensors have become smart sensors. People are becoming smart people. Everything is smart now. So this smart grid is possible only with superconducting magnetic energy storage devices. Next slide, please. So this is what we have seen. Whenever there is a short circuit, voltage is suddenly falling. And in SMES, you produce a mirror image of that. That means whatever is falling, exactly that much you add. This is some people do use even Fourier transformers, etc. But a simple signal theory analysis, everybody will say that whenever a signal is becoming, the amplitude of the signal is falling down, the superconducting magnetic energy storage gives a reverse signal of that extra that is requirement. Then immediately there will be constant voltage. That the slide earlier that I have shown was a power stability. Here this is called voltage stability. Next slide, please. So now finally at the end of the whole story, after 30-40 years, our generation is comfortable. But when these girls and boys are becoming professors and scientists and engineers and leaders and industrialists, there will not be coal, there will not be gas, there will not be fuel, nothing, no electricity, only simplicity, nothing will be there. All the computers will be off, all the electronic things will be off because there is no current. So people have to go for renewable energy sources right now. By that time, all the coal is out, all the natural gas is out. We have to be mentally prepared only by the 3-4 sources. One is wind energy, other is solar energy. Of course, nuclear energy is there, but nuclear energy is dangerous and costly and all sorts of things. Whereas renewable, nature has given solar and wind. These two energy sources are also can be made to work with superconducting materials. This is called superconducting wind generator that I have shown. Lack of time, I will not be showing. But what is important here is this superconducting or any, for example, even even the wind generators are there on Tirumala Hills. If you go there, when you are just getting down from the bus, you will see a wind generators on the top of that choul tree. And you will also see solar dishes, all of them. Why? Because they will supply, but they will supply fluctuating voltage, fluctuating power. That's not allowed by us. So what to do? That's why wind energy, all these things, though we know the in principles of it, but we are not able to use. We still make National Thermal Power Process, NTPC. We still fail all these other sources like natural gas based. Wind, even the solar energy people say, wind energy people say, but it's not being used in the Hyderabad city or Tirupati city. This is okay, fine, but it's not used. They are stylish words. When they will be used, when there is an energy storage related to that, so that the fluctuations are not there, the fluctuations are damped by this energy storage, so that the customer will not feel the fluctuating voltage, even though it is renewable energy, but it's not fluctuating, then it is very good. Next slide, please. Yeah. So that fluctuating, that wind, that left side, you'll see that wind turbine I am showing again. And this is the typical inverters and doubly fed induction generators. Electrical people will know it contains power electronics, thyristors, and all sorts of things. This any electrical engineer will know it. And right side I have shown a superconducting magnet. I am coming to an end. Don't worry. Within another 5-10 minutes we'll stop. Okay. So this is an example of wind energy system, and such wind energy systems are going to be playing a very important role after 40 years because NTPC has to close because there is no thermal power. There is no coal. What to do? So that's why you will see nowadays, now and then you get advertisements, BHL, NTPC, all of them are having 10 to 20% of their money, they are converting into renewables. And there are very, very small scale, distributed small scale energy generator people who are using solar energy based. And governments are encouraging on your rooftop, you make your own solar. But nobody comes forward. But after 10-15 years, they have to come forward. At that time, that power that is coming from these renewable energies, when they are fluctuating, another nuisance starts. Then how to stop that? Then you have to store superconducting magnetic energy storage. Right now, it may look like a difficult technology. After 20 years, it's no more. Just like resources are going down, but the technologies will come up. A very unusual combination. Lot of knowledge, lot of science, lot of engineering, but resources are less. Environment is polluted. A beautiful combination physicists have to answer. So that's why the future material is superconducting magnetic energy storage with renewable energy sources when all the sources are out. So next slide, please. So all over the world, people are working to make various SMES coils. Just coil means nothing but a solenoidal coils. If you arrange all the solenoid coils in a round, like a necklace, then it becomes toroidal coils. Solenoidal coils, field will be outside coming, whereas toroidal coils, field is confined. All these things are taught in 12th class. So this is the technology. Next slide, please. So now I am coming to the last slide almost. So this is the research projects we are now handling in Applied Superconductivity Laboratory in IIT Kharagpur. And you see right side, Power Grid Corporation, Central Power Research Institute, BHL R&D, Crompton Greaves, Institute of Plasma Research. All of them are supporting our lab where I am handling that lab. How? Because they need these technologies. Otherwise, they will not come. Earlier, they have not come. Because of materials, because of physicists have helped to discover a superconductor at high temperature. Now, if they discover room temperature, people will run after the physics department because it is only the physics department people give superconductors. Once superconducting things, materials are available, then metallurgists will make it into wires and electrical engineers will make it into coils, and Power Grid Corporation will make generators, transformers, chokes, coils, transmission lines out of it. So all the industries, power research institutes, BHL, Crompton Greaves, heavily dependent on, they are waiting for physics department of Mahila University to produce superconductors at room temperature. Next slide, please. So this, I end my talk by saying that HTS materials are going to play heavy role in future. Of course, associated cryogenic refrigeration is also required. A beautiful combination of electrical engineering from the Mahila University department and mechanical engineers who are very good in refrigeration engineering. If they join hands and apply some 5 crore rupee project, I can help you in writing a proposal, no problem about it. I can be advisor also along with you. And if you ask 10 crores, you'll get 1 crore definitely. You can start somewhere and you can do this energy storage. What you will be doing, you write to these people, various industry people, like superconducting generator motor, superconducting energy storage, superconducting power transmission cables, superconducting fault current cables, superconducting transformers. These 5 are the building blocks of electrical engineering. Power sector. Power cannot be there without transmission. Power cannot be there without fault transmission. Switch gear, that's called current limiter. Power cannot be there with transformer. Power cannot be there if there is no energy storage. Power cannot be there when there is no generator. And when you want to use the power, you only use the motor that will use. So IIT Kharagpur, in collaboration with all the slightly raise the slide, please. I will take another 2-3 minutes. That's all. Come down. Still, come down. Ah, yes, stop. So right now we are collaborating with IIT Kharagpur, CPRI, Bangalore, Power Grid Corporation, BHL, Crompton Gives, Mumbai, and VECC, Calcutta, Nuclear Organization. Many people are coming. When we started, nobody was there with us. We don't know. We started with some materials in a physics department type. So today we are having that. Same thing can happen easily in a better city, because Kharagpur is a village. In the cities like Tirupati, definitely it can happen in universities with those days, 30 years back, we never had a communication, we never had cell phones, etc. But today, everything is available. Next slide, please. So we want collaboration with the Mahila University, physics, material science, bioscience, electrical engineering, mechanical engineering, instrumentation and computational facilities and mathematics department to think of all these advanced technologies and inform all the industries to participate in the growth of power sector using renewable energies based on superconducting energy storage. Am I audible?
Yeah, audible.
So with this introduction of SMES, I thank you very much.
So thank you very much, sir, for your valuable and extensive talk on superconducting and storage materials and their applications useful to many people, and many departments can involve in this work. I hope our Mahila University also will involve and take your help and advantage to proceed further. Thank you very much, sir.
I also thank Professor Krishnaya and other people, Subhashini, all these people, I know them very well. And similarly, the administration of Mahila University, vice chancellors and principals and registers, all of them are kind enough to give me this opportunity to interact with you. And I was the alumni of SV University. I will be happy to come again and again and interact with you. And Krishnaya Saab is my teacher, and he is my senior also in PhD time, and he was also teacher. He taught us X-rays, and we still remember. I used to get a lot of nervousness in the X-ray because high voltages, etc. And he used to tell nothing, no problem, just to put it, you will get the lave pattern. I still remember. And I also thank all the authorities and everybody who has made this possible.
Okay, thank you, sir. Thank you very much. I think we'll take questions. There are no time actually. Maybe others, those who are interested, they can interact with Professor V.V. Rao for a further discussion.
My website, you can give my email ID, and
Okay.
I'm sure if they send question and if they can phone to me, no problem. We will be able to discuss any amount of time.
Okay.
And if some good physics people or electrical or mechanical, if they want to do internships or any little bit of projects, micro projects or mini projects, I can help them in getting international publications for them along with their supervisors, and we can do work together. Basically, my mind is always locked to my alma mater, so I always want to serve my SU University and Mahila University.
Thank you, sir. Thank you very much, sir. Thank you. Thank you. Okay, I will take for the next lecture, and I request Mrs. Rajita Madam to introduce our eminent professor, Professor G.K. Jayasankar, and please introduce.
Hello, good afternoon to all. Myself Rajita from Physics Department. Now I would like to introduce about Professor C.K. Jayasankar sir. Professor C.K. Jayasankar sir was born at Chittoor district, Andhra Pradesh. He received his BSc, MSc and PhD degrees in physics from Sri Venkateswara University, Tirupati. He worked as a postdoctoral fellow under the guidance of Professor Thierry Pocher in the field of laser physics, France. He also worked as a postdoctoral research associate in the Department of Chemistry, University of Virginia, USA, with Professor F.S. Richardson. Afterwards, he also worked as a senior research assistant in the Department of Physics, University of Hong Kong. He was joined as an assistant professor in the Department of Physics, Sri Venkateswara University, Tirupati, in 1989, and elevated to associate professor in 1998, and promoted as a professor in 2006. He has been visited
several universities or institutes under various capacities. He has 3 decades of rich experience in the preparation, characterization, and optimization of variety of lanthanide doped glasses, glass ceramics, and nanocrystalline materials for the development of laser systems, optical fiber amplifiers, pressure and temperature sensors, solid state lighting, and buried waveguides. Finally, he has both teaching and research experience of more than 30 years. Sir guided 28 PhD and 10 MPhil students. Sir published 306 research papers and co-authored 432 papers. Finally, Sir awarded 78th World Best Scientist and 4th Best Scientist in India, which published by Applied Physics of Stanford University, USA recently.
Hello. I now invite Professor Jayasankar sir to start the talk. Hello.
Hello.
Jayasankar sir, you
Good
can start.
evening to one and all. I'm just trying to how to share my screen. Let me see. Are you able to see now?
Yes, yes, yes. Okay.
Are you able to see the screen?
Yes, sir.
Hello?
Yes, sir. Yes, sir. It
Yes,
is
sir.
Are you
Yes,
able to see the screen?
yes, yes, yes.
Okay, thank you very much for allowing me to share my knowledge. And I also thank Professor Vasudev Rao, who is supposed to be my senior. He is senior and I am junior in physics department, SV University. So we know him very well. And at the same time, after hearing his excellent talk on energy storage, how lovely he thought and so on, really he proved to be my senior. And I want to give the credit for him. Sir, background is vasta undi. No, some background is coming. Hello? Is it clear?
Now okay, sir. Now okay.
My voice is clear?
Yes, yes.
Yes, sir. Yes, sir.
Okay, please see that there is some background. Anyway, so Professor Vasudev Rao is my senior and really did an extraordinary presentation on energy storage with living examples. And finally, he concluded that all are in the hands of scientists, particularly physics people, mechanical and electrical people. So in this respect, I really congratulate the people who are working in physics and mechanical engineering, and we are going to be helpful for the future generation as well as particularly in energy sector. And at the same time, my topic is going to be some materials where you can see also the energy, how the energy can be transformed from one form to other form, how that energy can be stored and how that can be utilized effectively to make vision. Because you see, for human beings are very much interested to see or listen, whatever it may be. Vision and listen can be modified, modulated and tuned as per your requirement only when there are materials in which we can do some optics. So energy materials, optical materials are going to be neck to neck for our societal applications. In this connection, let me share something about the rare earth doped materials for energy storage and photonic applications. And these rare earth doped materials means if you go to the periodic table, there are S black elements, P black elements, first group elements, alkali elements, halogens, and so on. Similarly, there are some elements in periodic table which we call it as rare earth. Those elements are having electron, outermost valence electrons in 4f and 5f orbits, which we call it as rare earth doped materials. If at all any rare earth contains in any material, and these rarest properties, optical properties can be modulated and tuned so that you can have some applications, particularly laser gain media, fiber amplifiers, sensors, pressure sensors, optical sensors, whatnot, even by modulating the energy through electrical or magnetic or whatever it may be. And this is what I am going to share. and now I am quite sure I should not exceed more than 5 o'clock. Whatever may be time given, I will try to do as best as I can. And now, you see, education is not the learning facts, but the training, inspiring of the mind to think. So whatever you learn, it is not going to fetch anything unless you inspired by listening this talk. So try to inspire yourself, try to understand how that can be extended in yourself by inspiring and creativity. Creativity and inspiration is an individual effort and individual interest, and that's what we are expecting from you. After listening the earlier talk on energy or the optical materials, we have to do something how this will be useful for your career so that you will be one among best or you will be top among the best in the field of science and technology. And now just to see, today we are not having seminar because pandemic environment, I mean COVID-19 restricted us our movements and social functions and get together, and groupism is avoided. So in this respect, isolation is very, very, very important. You will be quarantined. So once you are quarantined, how best we can make use of time is very, very important. And today we are interacting with webinar because of quarantine, isolation. My dear friends, on another way, or interestingly, this isolation also very, very important so that you can sharp your mind, you can think something so that you can have some creativity. For example, sometime back you might have heard Sir Isaac Newton was invented gravitational power, gravitational force. This was invented when he was quarantined. He was sitting in his garden and he is able to calmly, once he was isolated, he is just able to observe how the apple is coming towards earth, why it is not going up. So that is his imagination and his creation and his inspiration. And with the observation, he is able to explain the gravitational forces. Without gravitational forces, there might be no aeroplanes, no satellites, no movements, nothing could happen in science and technology. And now this was happened only when he was isolated due to quarantine. So though we are going to stay at home, better to sharpen our minds in a different way so that you have to make your use of our time is very, very important. And in your lifetime, time is the precious one. Who is making use of this time effectively and efficiently, they are going to reach their goals and they are going to be one among the best in the society. So don't make use of, don't waste your valuable time. Time is highly preciously maximum utilized with the minimum wastage of the time. That's what I can say. Quarantine is very, very gift for us to do something good things. And now you see, just now Professor Vasudev Rao told me, discuss about the materials. And today we are able to see the progress and prosperity in science and technology based on only these three factors. Electromagnetic waves, he already initially mentioned what do you mean by electric field and magnetic field and which are together. And electromagnetic waves, advances in material science and computational capabilities. These are the three key factors which is ruling today's science and technology so that our society is doing something better than earlier. And now, what do you mean by electromagnetic waves? Where it is coming from? It is just simply naturally coming from sunlight, and human beings with their science and technology, they are able to produce the electromagnetic waves, which is much, much higher than even the light coming from sunlight. And that example is laser science and technology. With the help of laser, you can get much, much more energy than the sunlight. And similarly, advances in material science. Today, you are able to see the materials which have multifunctional activities and functions. For example, you may have in your hand cell phone. You are calling it as a cell phone. That means it may be used only to call someone or to receive call from someone. Do you think that is the only agenda in your cell phone? You can take pictures, you can store the data images, you can take photograph, you can listen radio, and you can send messages, audio and video, what not. So that is because of a material is able to give some multiple functions. It can store the data, it can process the data, it can image the data, it can also communicate the data. So a material has been developed in such a way, it is going to have multiple functions, functional materials and recent sense materials or energy storage or whatever it may be, all depending upon the material science. The third one is computational capabilities. For example, today it is raining. With one stroke, you can get where the maximum rain and where the wind velocity, how it is, in which direction it is, everything it is being computerized so that you are able to get all information with one stroke. Similarly, today we are experiencing the COVID environment. And now, my dear friends, you can strike, you can just hit the button and you can say immediately, as on today, how many have been affected with COVID worldwide. And also I can say how many in USA, and also I can say how many in India, and I immediately can say how many in Tirupati, and also how many in Maida University, how many in SV University, or at least I can say within 1 kilometer how many patients are there. Everything has been digitized so that the computational capabilities are so rich that is beyond the human power, my minding. Because if I want to do 2 by 3, I can say 1 by 3 like that. 2 plus 3, I can say 5. If I say 22 plus 22, I can say 44. Suppose if I say 2 million plus 2 million plus 3 million, I need some time to do it. Whereas the computer will do it with no time. So that is what I am telling. Today we are able to see the progress and prosperity just because of these 3 milestones. One is the significant role by the electromagnetic waves. The natural light is coming from the sunlight, for example. Advances in material science. Today you are having materials which are having, if you want to be electrically good, magnetically good, thermally good, optically good, whatever you want, you can elect and select the materials. And similarly, you can do any mathematical computation with no time. And these are the 3 factors that ruling science and technology, in which what is our role, what are the deficiencies, what is the status of the knowledge, what we can contribute to tomorrow is the main objective of this seminar. So today we are listening. With this listening, now you see what is going on, how it is useful, where is the problem, can we solve those problems, we can identify the problems, can I solve the problems, how far I can solve the problems with much more efficient way, reliable way, justifiable way, and that should not damage our environment. That is another important point. So this is the objective of this webinar. Try to learn what is going on, what is the status, is there any problem? If those are the problems, then you have to contribute it. That is our motto. That's what Professor Vasudev Rao is telling. You see, superconductors has to work at room temperature with minimum resistance. How the energy can be stored, how that energy can be utilized wherever there is a demand. So these are all very, very important in any materials, and storage of the materials is just nothing but keeping the money in the bank. So you can keep the money in the bank and you can draw wherever you want. There is a financial audit, and similarly there should be an energy audit, energy storage audit, and also material audit. And in this respect, the Maida University is very, very timely and efficiently well planned to have the material science, and this is very, very important in my opinion. Now, let us say I am talking about electromagnetic waves. The first one, do you think electromagnetic is just sunlight? With that, you are able to learn many, many things. And you people might have heard about the Science Day or Independence Day or Teachers Day, whatever it may be, and even Father's Day, Mother's Day, like that. So there is some speciality, there is some speciality, there is some significance. If at all you are celebrating Science Day, means that is the day when real science was born in India, that fetched the Nobel Prize. Similarly, we are conducting the Teachers Day. That the day Dr. Sarvepalli Radhakrishna was born, he became president because he started his profession as a teacher and he was elevated to the president of India. So we have to reciprocate, we have to learn something from him. Not only we are saluting his contribution, we are going to inspire by taking his history and his lifestyle and the way of functioning, so that you have to be created and you have to be doing something on it. Similarly, the United Nations organization, which controls the entire science and technology, whatnot, all aspects of the human beings worldwide. So that is called United Nations organization. And this United Organization has identified the importance of science and technology. Whoever has contributed, like Science Day, Teachers Day, and Children's Day, then they also framed some important celebrations. For example, 2005 has been celebrated as International Year of Physics. Why they have called as International Year of Physics 2005 is because in 1905, the great scientist Albert Einstein has contributed three famous physics principles. For example, photoelectric effect, theory of relativity, photoelectric effect, theory of relativity, and the other one is Brownian motion, and so on. So because of these three, ruled the entire science and technology and changed the lifestyle, and the science and technology has progressed like anything. And because of exactly after 100 years, it was called as International Year of Physics, because Professor Vasudev Rao told physics is really backbone for entire science, I am telling you. So the first time in the history of United Nations Organization, first time they have recognized 2005 as International Year of Physics. And similarly, my dear friends, 2015 has been recognized as International Year of Light. Without light, there is no life. I say immediately. When there is a light, there is a life. So you see, without light, you can't do anything. For example, you take the Mahabharata, people are might have watching the TV serials or whatever it may be. Mahabharata Yuddha fight will start only sunrise and close by sunset. Of course, later on it has also polluted. Forget about in the beginning, there is a principle, the war will start only from sunrise and sunset. Why? Because sunlight only we can see naturally, easily, and we can justify what we are doing. So similarly, the importance of light, who invented light, who wrote a book on light, and so on. They have checked everything and so on. Exactly in, my dear friend, 1015, there is a famous optics book written by Alhazen, and that book became famous in optics because you might have heard Bible, Quran, Mahabharata, because these are all the monuments for their different religions. Similarly, the first book written in 1015 is a Bible for entire optics, and that is why 2015 has been named as International Year of Light. And similarly, my dear friends, 16th May is called as International. Am I audible? Hello? 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 Am I audible?
Yes, sir. Audible.
Hello?
Yes, sir.
Audible?
Audible.
Okay, okay, because power has gone
Yes, sir, it is
in my
audible, sir.
place.
Yeah, audible, sir.
So if Professor Krishna, I request Professor Krishna, if it is not audible, please call me, because we are getting power fluctuations and then also net problem.
Yes, sir.
Please.
Yes,
You
sir.
have to
Sir, it is
update if there
audible,
is any
sir.
problem.
Okay,
Okay,
sir.
anyway, so 2015 has been named as International Year of Light, and similarly International Day of Light is called as 16th May, because 16th May 1960 a new form of light was born, that is nothing but laser light. And without laser, there is no progress in science and technology. For example, you see, you might have heard Raman effect, and now Raman effect has been accelerated like anything just because of invention of the lasers. Similarly, your communication technology has been accelerated just because of lasers and fibers. Without laser and without fiber, there is no communication. And you might have seen the copper wire, which was shown by Professor Vasudev Rao, and even the fibers looks like even smaller diameter than the copper wire. You can hold the copper wire, it is around 1 millimeter, where the fiber is having only micron. If at all anybody is having knowing the fiber optics, the core and clad all together is going to be only around 200 microns, which is just similar to our human air, because human air is 100 micrometers. So the fiber is having around 100 micrometers. And now with that you are able to communicate. Today we are listening our webinar because of fibers, and where there is a laser light. Optics have been modulated in such a way that carries some information. That information is maybe a voice or audio or video, or it may be. So without laser today, our webinar is going to be completely ruled out. And that laser was born on 16th May, and that is why 16th May every year is going to be called as International Day of Life. So what I want to tell is, I'm being a spectroscopist. Professor Krishna told that I am a specialist spectroscopist. I want to highlight what is the importance of spectroscopy. And also one more important point is, spectroscopy is a branch of science that you can see in every branch of science. I repeat once again, spectroscopy is a sub-branch of science. The sub-branch can be seen in any science of the system, even including arts and commerce and so on, that I will tell you later on if you wish. And now, you might have heard that Nobel Prizes, for example, Sir C.V. Raman is the first Asian who got Nobel Prize in physics. He worked in only optics, spectroscopy. And now, if you take the entire list of the spectroscopy, physics, chemistry, medicine, in all these three subjects, there should be an optical analytical tool which has been used as an analytical tool to characterize their material or to characterize their synthesis or phenomena or whatever it may be. And now, if you take the entire list of Nobel laureates, without lasers, without light, there is no possibility of having semi inventions or whatever it may be. So most of the people who are getting Nobel Prize directly or indirectly use laser beams or electromagnetic waves and so on. And out of them, most of them got Nobel Prize because they are dealing with only the properties, characterization, and how that can be modulated, how that can be extracted, utilized, and so on. Their properties and utilities and characterization all are related to electromagnetic waves. And within that light, most of them are got Nobel Prize. Whoever able to explain the properties of the lasers or electromagnetic waves and their applications and so on. And now, just to see, whatever it is a energy material, it is a electric or magnetic or whatever it may be, even optical materials, first you should know what is that material. And in order to know the basics of the material, its structure is very important. Its structure can be explained only an atom. How an atom is a building block for any material, and without understanding the atom, it may not be that easy to understand the material and also to modify the material properties to have any practical application, maybe energy storage materials of magnetic or electric or optical or thermal, whatever it may be. So you should know the structure of the material. And in order to know the structure of the material, the building block of any material is at atomic level. So you should know what do you mean by atom. Atom is nothing but centrally positive nucleus surrounded by revolving negatively charged electrons. And this is simply an atomic structure. And now, when atoms, more than one atom or two atoms are joined together, then you'll see a molecule. So a complex, you take any energy material, whatever it may be, a building block is an atom. And atom is not only a single atom. It may be combined with some ligand or some other metal and so on. You will get a molecule. Once there is a material, there is a building block, an atom, and also a molecule. And different molecules or group of molecules makes a complex. And those complexes are going to be utilized for practical purpose, or you are going to modify those properties. Because you see, when a material is formed by combining two atoms, how best you are able to combine two different atoms so that you will get a new property is our aim of the goal. How that can be utilized for energy storage, or how that can be used for optical materials and so on. So how a material can be synthesized artificially as per your requirement is the basic research for anybody should know it. So a material is having a molecule is having an atom. So these are the way how the atoms or molecules are combined together. Once a molecule is formed, for example, CO2 or CO, and this is oxygen, this is C, and similarly this is oxygen, this is C. And now once a molecule is formed, these atoms, one is having positive charge, the other one is negative charge. Positive is always pulling the negative and negative is always pulling. So there is a vibration between two atoms. And similarly, there might be a rotation. And these are the factors that influences any chemical, physical properties of the material. My dear friends, I repeat once again, once a molecule is formed, these molecules are formed because you are having two atoms, and these two atoms may be homo or hetero, category, and once it is hetero or homo, these two atoms are going to add together, having some ionic bond or covalent bond or a single bond or whatnot. Many types of bonds will exist, and even if there's a covalent bond, how strong it is, even ionic bond, how strong it is, and once these bonds are formed, the molecules will never be rest. It may vibrate or it may rotate. At the same time, these vibrational rotational properties are going to dictate its physical and chemical properties, and that's what I want to tell you. Once a molecule is formed, you have to evaluate the vibrational rotational energy of the molecule. That will tell you indirectly what is the material properties. For example, even if you talk about semiconductors band theory, you might have heard Cronin-Penny model, where you are able to tell the bonding or band, forbidden band or allowed band or whatever it may be. In all those aspects, one should know these informations. And similarly, you see, when the molecule is formed, and now, as I told you, the molecule vibrates, rotates. At the same time, when there is an atom, the outermost electron or innermost electron may jump from its orbit to other orbit, depending upon how much energy it is received. Depending upon the energy received by any molecular system or atomic system, the electrons may jump from its normal state to the higher levels. If those levels are quantized, if the incident energy and the electron jump coincide any of the two orbits, then only the electrons will jump from one orbit to other orbit. That is called, we call it an absorption. And this is called an absorbance. You see, the instant energy that exactly matches these two energy levels, then only the electron jumps from here to here by taking the energy from the incident. This is called absorption. And now, once the energy system gets absorbed, what will happen is it will stay here. And now you say, I can stay here. Very simply, once the electron jumps here, it will stay some time. And I mean, you are able to store the energy in higher state for some time. And now, if the energy is staying for relatively longer time, then in optics, you are going to call it a metastable state. Metastable state is nothing but the atoms, once it jumps to the higher state, it will stay relatively longer time. And now once it's relatively longer time, it will slowly release one by one, because now there is not only one electron. The system is having millions of the electrons. You know, you might have heard Avogadro number. You just see Avogadro number, and that clearly says how many atoms are there, and each atom may contribute to excite electron from ground state to excited state. And now when the energy is falling on the system, the electron takes its energy and it goes to higher state. It will stay as long as it wishes, depending upon the environment, chemical bonding, ionic bonding, molecular structure, and so on. And now this is a metastable state. That means the excited electron is staying here, which is normally higher energy. It will slowly try to come back. While coming back, it releases the energy. And now the energy is stored in higher state and it will be released slowly, and depending upon the metastable lifetime. For example, my dear friends, in the night you are able to see the border green and red. When light falls on it, it keeps on emitting hours together. That means the light falls on the material, that light absorbs that border material or indicator or whatever it may be. While you are in the traffic signals, there is a border, or even there in the vehicle, there is a green belt, green color belt or indicator. Once light falls on it, that blue or green or red keeps on glowing. So that means energy was received by that paint or whatever it may be. It stores and slowly releases, so that you are able to see there is a vehicle, there is a border, and there is a dead end of the road, like that. So energy has been stored, optical energy, where you are able to see the electrical energy. Here, I tell you very simply, once the energy received by this atomic system or molecular system, it goes to excited state. And now the lifetime may, depending upon the environment and material properties, there are so many. And depending upon the material properties, it may stay here 1 microsecond, 1 nanosecond, 1 hour, or even 1 day. That is the research going on. And now, once you are able to store one, instead of 1 hour, instead of 1 minute, then there is a storage of optical energy is much more. And similarly, if at all you are able to store the electrons one day, that's really great achievement. So when you are able to talk about superconductors, where the resistance is going to be negligible, and similarly here in optics, if any excited electron goes to excited state, if at all it stays relatively longer time than expected, that is a great achievement. So instead of 1 minute, if at all you are able to get 1 day, really great achievement. So this is the research going on in optical materials, where the energy storage is very important. Once energy storage is very important, you can do many applications like laser gate media, fiber amplifiers, sensors, whatnot. So very simply, I am explaining how the optical energy can be stored in the excited state depending upon its lifetime. And now that's what I'm telling. So once it is excited, it will go here. And you see why it has to come back means the atom gets excited. The excited atom is unstable. Whereas if the electron is the ground state, is a stable one. And the electron goes to excited state, is unstable. So in order to have its stability, it has to come back. And it may come back after a minute, after a microsecond, after 1 hour, or 1 day, depending upon the structure material properties. And similarly, how the intensity are going to be recorded with the help of spectrometer. How this part of energy is absorbed, this part of energy is emitted. And these are all mainly due to spectrograph, spectrophotometer, and spectrometer. So advances in material science, similarly, advances in analytical techniques, spectrometer becomes spectrograph, spectrograph becomes spectrophotometer, and today everyone is handling spectrophotometer, and now you are able to see the signal like this. This is the way how absorption shows, and this is how the emission shows. And now just to see, as I told you, when there is a molecule is formed, there are different types of energy levels. For example, if at all an atom, the electron jumps from one state to other state, one orbit, other orbit. So this is the electronic level, and this is the another electronic level. And now, if the molecule is formed, in addition to electronic levels, there are vibrational levels and there are rotational levels. Each electronic level is associated vibration level. Again, each vibration level is associated with rotational level. So each electronic level of a molecule is associated vibrational levels, and in turn vibration levels are associated with rotation levels. So if at all there is a transition taking place one electronic level of other electronic level within a molecule, there might not be only single line, there might be many more lines. You can see group of lines. For example, from this vibration level to any of this vibration level, or from this vibration level to any of the rotation level, lower rotation. So you can see there are so many transitions, where in the case of atomic system, you are able to see only one level from one electronic level to other electronic level, whereas in the molecule, you are able to see group of lines. That's why you call band structure. And now, my dear friends, how the transition will take place, what is the intensity, and everything depends upon the selection rule, quantum selection rule. Energies are quantized, and selection rule tell you whether transition between one vibration level to other vibration will take place, or one rotation level to other rotation will take place, or its associated vibration levels, or its associated electronic levels. So if at all you are able to synthesize any material, and if at all you are able to establish the electronic levels, vibration levels, and rotation levels, and now you are able to characterize that material. Once the material has been characterized, I can say immediately whether that material is going to have any practical applications, either its thermal property or electrical property or magnetic property or optical property. So all those properties are going to be decided only this energy level structure, because from this energy level structure, you are able to get valuable information. That's what I can say, fingerprint analysis, I can say. So fingerprint analysis means each human being is having its own fingerprint that cannot be duplicated even within the family in future or in past. So a unique fingerprint is unique. Similarly, you take any material, if at all the material is different, that means any of its property should be different. Once the property you are making it different, then definitely you can plan for any practical applications. That's what our motive, and that's what our creation, that's what our imagination, and that's what we have to contribute in science and technology. And now just to see a simple way, and this is the matter, and this is the quantized energy, because physics people or spectroscope people know that the quantized energy means the electromagnetic waves. Teeny energy is nothing but quantized, which we call it as h nu. H is Planck's constant and nu the frequency of the light, and this light is allowed to fall on a matter. Just to see, I am repeating once again. This is the electromagnetic wave, quantized photon, and now it is allowed to interact with matter. Once it interacts, various phenomena will take place. Just see various phenomena. Once the radiation allowed to interact with matter, it may be absorbed, it may be scattered, or it may be transmitted, it may be diffracted, or some energy may be emitted. And now, my dear friends, you know what is the incident energy? And your analytical technique will tell you what is the absorbed energy, what is scattered energy, or what is the emitted energy, what is the diffracted energy. And now, you know incident energy, you know diffracted energy. With these two, I can tell what is the matter. That is the important of point you have to remember. You see, you know what is the incident energy. This incident energy has been scattered or emitted or diffracted, transmitted because of the material. Material gets interacted. So that interaction reaches these things. And now, for example, if at all you are able to send a H nu, and if at all you do diffraction, and I can say what is the structure of the material. And similarly, if at all I am able to collect the scattered radiation, and I can tell what is the vibrational rotation energy of the molecule. And similarly, if at all I am able to absorption and emission, I can evaluate the electronic structure of the materials. Like that, each property is having its own importance. For example, why it is so? Because as I told you, most of them are got Nobel Prize because electromagnetic waves are having these properties. What is its energy and what is its wavelength? For example, X-rays is having around 10 nanometers, and visible reality is having around 400 nanometers, and your fiber communication is having 1.56 micrometer, like different wavelengths. So each electromagnetic wave is having its own wavelength. And similarly, its intensity also is different. And polarization, you might have heard polarization and coherence phase. So you take any of these electromagnetic waves, these are the properties that electromagnetic waves are having. And this research on these properties lists many, many Nobel Prizes. And also they are able to tell whether electromagnetic waves or particles, all these things only. And now for our discussion, once the electromagnetic waves are having these properties, and when it interacted with the matter, any of these properties gets modulated. Any of these properties are all properties. So, and what is the modulation? That will tell the material. That's what you should remember, my dear friends. Electromagnetic wave quantized energy is allowed to interact with the matter. And once it gets interacted, some of its properties or all the properties or partially some of the properties gets modulated, not changing, because electronic people know what do you mean by modulation. You are able to modify some of its properties. That modification carries some information. And similarly, any of these properties gets modulated, and that modulation can be seen through diffraction or emission or scattering or absorption. And now I will tell the material. So this is the fingerprint analysis of spectroscopic technique. And now come to the point. This matter may be newly synthesized material or naturally available material from the earth or seashore or whatever it may be, or even the material collected from the moon, whatever it may be. So today nano science, tomorrow some other material will come. Today nano material that has to be characterized only with the electromagnetic waves. So whether the material is having any importance, that material should be characterized any of these techniques. And for all these techniques, electromagnetic waves are very, very important. And now any of these properties are going to change. This is what we are doing in our lifetime, because Professor Vasudev is telling that he is able to work on superconductors. Similarly, we are working only optical materials. We're using the analytical techniques. We are able to characterize those materials so that whether it is going to have any practical applications or not. At the same time, even if they are not having any practical applications, I can tell at least what is the science of the material. Because if you take any material, the science of material is very, very, for example, what is its color, what is its density, what is its volume. That's a physical property. Similarly, the science of the material means not only physical properties, what type of materials made. Once the what type of materials are made, what are the bonding, what is the ligand. So there are so many chemical properties. So all those things we are going to tell. So that is the science of the material. Those science will that the characterized properties or quantified properties may be helpful for any practical applications or not. That totally different. And now just to come to the next point, and now just to see once scattering takes place, I mean, once the interaction taking place between material, these are the phenomena will take which I have absorption, emission, transmission, refraction, reflection, diffraction, luminescence. And now all this, any of them, so you see, take for example absorption and emission. If at all you want to get laser properties, laser gain media, you might have heard when you are talking about lasers, Einstein coefficients, which are nothing but transition probabilities. And those transition probabilities can be established only through absorption and emission properties, and what the emission wavelength, why that line is very, very intense, or whether that light is polarized or not. Everything I am able to get from absorption and emission. Similarly, transmission. You see, we have to see a good material, maybe, for example, a window or a lens or a thermometer. For example, you measure temperature, and where the transmission is very, very important. Similarly, communication. Refraction, for example, you might heard next diffraction, whether the crystal is uniaxial or biaxial. Because if at all there is not uniaxial, you will get refraction, double refraction, and so on. And that's what we are going to get. And similarly, reflection. Total internal reflection is very, very, very important, and that allows you to have fiber optics. And diffraction, as I told you, entire crystallography, the science of crystals and structure of the crystal depends upon diffraction only. And now luminescence, as I told you, all display devices at present, you are watching this webinar, you are having some screen. That screen is having some colors, and those colors may be a sharp or blurred, or sometimes when you change from one page to other page, there might be an overlap. It takes some time to change the screen. All those materials can be characterized and fully evaluated before going to have any practical applications. All display devices, your cell phone or your TV or your mobile phone, or even the street, there might be some screens. All those are having display devices based on luminescence materials, because it takes some energy and then it emits visible light. See, whatever energy, it may be visible or infrared or ultraviolet or X-rays, it takes some energy and then it emits in the visible region. Then those materials called luminescence materials, because you are able to see in your naked eye. There are so many, the electromagnets are having very huge family, from gamma rays to radio waves. Out of huge family, you are able to see only part of the region which we call the visible light. So if at all you want to see any material, that material should emit some color, and that material is called luminescence material, which is used for display devices. And now you see the material science, as I told you, material science is not simple one day show. The material science depends upon physics and chemistry. And today we are talking about energy storage materials. So materials may be of optical, energy, magnetic, electrical. And once it's optical material, it may store optical energy, or optical energy can be manipulated. And for example, what all an energy is, with the material is energy material, you can store energy, you can retrieve the energy, you can modulate the energy. And similarly, a magnetic material, if at all there is a magnetic material, that magnetic properties may be enhanced or quenched or stored or retrieved, or we can modify it. Similarly, electrical. So take any materials, each material is having some its property. Those properties can be intelligently modulated so that you can store, you can retrieve, you can increase the capacity, or whatever it may be. For all those things, material science is very, very important. In those material science, physics and chemistry of the material is very, very important. So you take any nano science or technology, crystal growth, thin films, variety of the materials, all these materials are having different applications, and where there is a material. And now all these material properties has been fully characterized to have any practical applications only by using the spectroscopic technique, analytical technique. That's what I want to tell you. Because earlier I told you, a quantized electromagnetic wave is allowed to interact with the material that interaction is different phenomena, and those phenomena you are able to evaluate, and then you are able to characterize the material. So any of the material, optical, electrical, or nanoscience, or crystal, whether crystal was grown properly or not, or thin films are made or not, and also in solar energy, solar emitting diodes, materials in fiber optics, biology, zoology, everywhere there is a material, and those materials can be characterized only from spectroscopic technique and analytical techniques. And now, just to see, as simply I will tell you, spectra is nothing but orderly arrangement of release of absorbed energy of an atom or molecule or ion. Earlier I told you, spectra is nothing but orderly arrangement of release or absorbed energy. And unfortunately, this is online. If it is offline, I might ask some questions. I might have seen how you are able to listening and how you are able to expressing your doubts. Now there is no scope. Only 5 minutes are left as per schedule, and I will try to finish up the knowledge as best as I can. And now the spectra is nothing but the orderly arrangement of absorbed or emitted energy that may be due to an atom or molecule or ion. And now, naturally synthesized biological system, for example, complex, can absorb or emit, if not maybe induced. This is a word. There are some materials may not emit, may not absorb. That is optically inactive. But you can make them active by doping. For example, a rare earth doped material. You take any of the garnets or a silver oxide or potassium dust, you take any inorganic material, colorless, it may not be spectroscopically active, but if at all add some impurities like D block elements or F block elements, those optical properties will change depending upon the environment. That change will reflect what is the host, what is the, so you are able to induce the properties. If not, that's what I am telling. So if not, maybe induced, sensitive to environment and structural composition, whatever the emitted or absorbed are all depending upon the environment, coordination number, ionic bonding, covalent bonding, all those things are going to influence your spectroscopic properties, and that spectroscopic properties will reflect what is the physical and chemical properties of the material, and now you can establish whether it is having any practical application. So, and now I don't want to talk because there is no time for me to tell all these things, and my research field is just to see out of many materials, for example, you might have heard many materials, gas, liquid, solid. And out of these three, the glass is a solid material, and we are working on this field, laser glass, glass science and technology. Without glass, there is no life. As I told you, light is life, and similarly now the science and technology or modern society is able to live only by touching or seeing or making use of those glasses. Today, just you see in front of me, there is a window glass, and your cell phone is having tamper glass. Your cell phone is having tamper glass. Similarly, your cell phone is your laptop is having glass. Everywhere there is a glass. You are taking water with the glass. For example, you go to chemistry lab. Do you think without beaker, without thermometer, without beaker, without flask, can you do any experiment? Similarly, if you go to physics, without glass, can you do any experiment? If you go to hospital, everywhere there is a glass. So glass is such an important material that makes our life so easy, comfortable, and we can do miracles on it. For example, if you go to old construction monuments like temples and churches or whatever it may be, you may miss to see the metals like iron or silver or whatever it may be, but definitely you can see a window glass, which is colored glass. So the glasses have been with us even for a long time. And those days, those glasses are only for decorative. I will repeat once again, those glasses only are decorative. And today, the same glass with our science and technology, you are able to make a fiber. You are able to make a laser gain media. And my dear friends, most of the ladies wearing the ornaments, those are all gemstones or nothing but glassy materials, but prepared in a special technique. So there is no death for glass. As long as human beings are living, as long as earth is surviving, there is a glass. Even without steel and without metal, you can live. But without glass, you cannot live, because whatever the purpose you are able to get from the metal, you are able to get it from a glass. For example, even batteries are made today with glassy material. That there is no time to share my knowledge. Even the glass materials are being used to construct your batteries. So glass is such an important material, and also that the only material can be used to construct from bulky sizes to complex miniature size. I repeat once again, glass is the only material which can be used to fabricate from bulky size to complex miniature size. Bulky size means our window glasses, and complex miniature size is our fibers. And whether you believe me or not, you go to internet and you type in the Google glass house, glass stations, glass train, and glass materials, glass manufacturing, and you can see in the images there are so many buildings which are constructed only a glass. For example, in Germany, Berlin railway station was constructed only with glass material. There is no metal at all. Where that is the beauty of the glass material. So even there is a bridge where the glass have been constructed so that that is a transparent. You can see what is going on inside, and you can see the out on top also. And there is a train constructed only in a glass in Canada. They are able to run a train, glassy train, so that that goes from beautiful tourist train, and you are able to enjoy the scenery like anything. You never feel that you are in a train, because the train is constructed by a glass, and now you are moving in the natural scenario. So glass is such a beautiful material, scientifically, academically, research, development, enjoyment, ornament, our decorative material. So this is the material, very, very important, and one can make that material even quite easily. My dear friends, making battery, energy analysis, storage is really very, very expensive. You need bulky material, you need many, many people. Whereas preparation of the glasses, just yourself is enough. You can prepare glass by yourself. You can characterize the material yourself, and you can identify whether that glass is going to have any practical, any applications of whatever I told you right now. And just to see, once upon this I'm telling. Now just to see, these are all the images I am showing, where you can see the glasses, where alcoholic bottles are your teacup, are your bakers, and as I told you, this is the monuments. Just to see colored glass, and your goggles, and your lens, and your laptop, your watch, your helmet, everything is made of fiber, which is amorphous material. And now for high energy, high power, you need a glass media. And similarly for fibers, you need only a glass material. And now glass are so many different types. I mean, phosphate glasses, silicate glasses, telluride glasses, gem, and so on. And there are different types of glasses. And how this glass can be made is very, very simple. For example, there is a glass, what all you call it, a borate, phosphate, silicate. Those are the major component. Phosphate is a major component in which you are able to add something so that you are able to modify the glass properties. For example, people should know there is a rice, and in that rice is the farmer. And if you add salt, then there is a salt to a rice. And if you add lemon, you can call it lemon rice. If you add tomato, you can call it a tomato rice. Each rice is having different taste and different property, different, and different people prefers different type of rice. And now same thing here also, there is a borate. You can add some alkali element or heavy metal oxide or something else. In periodic table there are more than 100 elements are there. Keep on adding the element, and you can modify its properties. And if at all you are lucky enough, if at all there is a best composition, you can get that glass is having some better utility or whatever it may. For example, you see, there are three elements. One is F, glass former, and this is a modifier. You can add any alkali elements, heavy metal oxide, whatever it may be. And A is the spectroscopically active ion, because the emission and absorption properties are going to be depending upon the electronic configuration. D block elements and M block elements are having valence electrons. Those electrons jumps from one orbit to other orbit. While jumping, it releases visible radiation. There are some other elements also, but we have to choose an element in periodic table so that its electronic transition should be in the visible region, because we are worried about our visible radiation. If at all those elements are able to give other than visible emission, then you have to use another material to convert to visible light. For example, you might have heard that there is X-rays, and X-rays you cannot see it. You are able to use the fluorescent screen, then you are able to see X-rays are generated. So Finally, you have to see them. So similarly, in periodic table, there are so many elements, and each element is able to emit its own energies. But there are some elements, particularly D block elements and F block elements. If those elements are participating in the transition, and those elements are able to emit visible radiation, that's why I'm using those rare earth elements instead of F block elements, instead of D block elements. That is a different story, because how the F block elements are preferable than D block elements. For that, we need another hour to discuss. And now just F and M and A, totally we have to see that 100%, because if at all you geometric ratio is very, very important. And now if at all I take 50-49, sorry, 50-49 and then 1. So it's 100. Instead of 50-49 1, I can take 60-39 1, or instead of 70-39 1. So like that, I keep on changing the composition, and depending upon the composition, its properties are going to change. So if at all I am lucky enough, if at all I am able to identify a good combination, either optically or electrically or magnetically or thermally, I am the luckiest person. So there is no death for research in glass science. You can keep on preparing the materials, and now you can do miracles in the research in the glass science and technology. That's what I am telling. Okay, and now you see, I think the time is already over, and this is what I'm telling. My research depends upon this only: laser glass science and technology. We are able to prepare variety of glasses, that may be a borate or silicate or phosphate, and we are modifying not only alkyl elements, alkaline elements, and also instead of one active ion, I may co-dope them. I mean, instead of one active ion, I can dope two elements. So like that, there are so many combinations are there. Day by day, things are going on. Previously, because you might have heard only lemon rice, curd rice, and ordinary rice. Today, you can go to a restaurant. There are so many different types of rice. For example, even if you go to a breakfast shop, they will say 100 types of doshas. They will say 100 types of doshas. Previously, there are only ordinary dosha and masala dosha. Today, you are able to say 100 types of doshas, and tomorrow you may go millions, and there is no end for number of doshas. Similarly, there is no end for the glass science and technology. You can keep on preparing those glasses, and so that those glasses are having multiple applications, either luminescent materials or energy storage materials, and so on. And simply, I will wind up only one diagram I will show you. Just to see in the brochure, they have shown that a color diagram. And now, just to see, any material is able to emit blue, green, and red. And these are the three major colors. Depending upon the environment, if at all I am able to these three colors equal emission, then I will get white light. And now sometimes green may be dominating, sometimes red may be dominating, in between intermediate colors. All depends upon the composition of the material. So I'm able to change the composition. I am able to change the concentration, and depending upon this chemical composition, I can get whatever color I want. Infinite colors I can get. These are all nothing but display devices. Like that, there are so many. And now sensors and solar cells. And this is what then batteries, how these batteries can be made glasses. So you see, in batteries energy storage, you might have heard right in the first session, or in future also you might have heard battery. And now there's anode, electrolyte, and the sorry, this is cathode. Sorry, this is cathode and electrolyte and anode. Previously, these are all one is electrolyte is amorphous and remaining two are crystalline materials. And today we are able to produce the battery only with the glass materials, where the functions and advantage is much more than the metallic batteries. And that's what rigorous research is going on. And this is what I want to tell you. And I have many things. And similarly, spectroscopy is a tool for everything. Even today, you might have heard this COVID-19 and so on. The COVID-19 can be analyzed through the electromagnetic waves only. Just they will collect the sputum and they take the spectra, and seeing the spectra, I can say whether they are affected with COVID or not. If at all affected, the intensity of the peak, the position of the peak will tell you whether it's COVID free or COVID affected, and the intensity will tell you how severe it is. And you might have heard this term oximeter or thermometer. These are all based on the infrared radiation, because our human beings are able to expose with infrared rays, and those infrared rays will be reflected, and depending upon the reflected wave, I am able to see the temperature, and also at the same time, I am able to evaluate the percentages of oxygen. So if at all you are familiar with spectroscopy, you can do any field of research, either medical or some physics or chemistry, or even you can get Nobel Prize. That's what I can say. And now I am quite sure that with the material science only, once upon a time, our forefathers or people are able to live in thatched house, and today we are able to live in the skyscrapers because advances in material science technology. And similarly, we are able to live, cook and everything with mud vessels, and today we are having life warranted vessels. And now the human beings are able to develop from here to here. You know how Darwin has been explained the evolution of the human being. At the same time, the science and technology have been evaluated over the time. We might have seen Buddha, Krishna, or Yesu, Einstein, Raman, and Abdul Kalam, and so on. These are all evolution. Not only science and technology, even the evolution of human beings and so on. And with this, I am just going to end up my talk because I don't want to take much time. The beginning may be late, but the ending should not be late. That's what my psychology, and nobody may be interested. And with this, I thank Maida University administration, and in particular, physics department, my teacher, Professor M. Krishna Garu, who taught X-ray diaphragm. As Vasudev Rao told earlier, we also went to X-ray lab and we learned the X-ray diaphragm method. Still, we remember how we struggled to do that experiment. Unfortunately, those experiments have been dismantled. I mean, the education system is also under crossroads. But whatever they taught earlier, that still remains in our mind, and that will helpful for us to reach this stage. So I thank once again Professor M. Krishnaya and his department for giving an opportunity to share my knowledge. In future, if there is a leisure time, I am ready to share. I am available within 5 kilometers from your institute to my house. So I am ready to share my knowledge through webinar if there is any time is available with you. With this, I thank one and all for your patience. Though the atmosphere is not good, though there is an internet problem, I thank you once again. Thank you very much.
Thank you. Thank you, sir.
Now the session is open for mattering.
Now the session is open for questions. Hello. Hello.
Yes, sir. I am available.
Okay. So those who are interested may put some questions to Professor Jayasankar. He is very, very happy to answer. There is a time for 2-3 minutes.
Hello, may I audible?
Yeah, audible.
Yes.
Sir, I have one doubt. So your lecture is very nice, and you taught the basic concepts in the materials in a good way. So I want to ask one basic question. So what parameters makes increase the electron lifetime in the excited state? That is what I have doubt from my
Lifetime?
What parameters makes the electron lifetime in the excited state?
Okay, all depends upon the phonon energy. You see, when the electron gets excited to excited state, it will come back. That depends upon the multi-phonon relaxation. There is a word. Multi-phonon relaxation means it is nothing but vibrational energy. If the vibrational energy is very, very less, then the lifetime will be more. That's the only point I remember right now. All depends upon the phonon energy of that material as on today. And similarly, for example, borates, silicates, and phosphates, and fluorides, chalk, there are different types of glass are there. All these glass are having different phonon energy. If the phonon energy is less, definitely the lifetime will be more. That's the easiest way to answer.
Thank you very much.
Anything else?
Sir, it was an excellent presentation by Jayasankar sir. VV Rao speaking. And really, I understood what is glass today.
Really?
Sir, I thank you very much, sir. I too learned many things from your energy and power. So far, I don't know the difference between energy and power. Today, I came to nobody will say energy cut. Everyone will say only power cut. Really, I remember that. And also, you are the person to make enjoyable in our classroom, sir. with your mimicry, with our songs. Really, we are very fortunate to be junior to you.
No, sir. It was really good. Your lecture, your preparation of slides, I have something to learn. It's very clear letters, and you have utilized the space very nicely. I will imitate that.
Thank you, sir. I all learned from you people, sir. Yesterday, Purandar called me. What is webinar? Where is he coming like that? He invited your classmate.
We are all missing Buddhudu.
Yeah. Not only Buddha, one more person also. He told me there are 3 persons missing. That's what the Purandar sir told me yesterday. And also you are having WhatsApp group. That's really very good idea, sir. We also having WhatsApp group. But I am thinking in future to keep all physics in one platform.
Yes, sir.
Very good, very good.
That's what I'm thinking.
Really, Krishna sir also is doing a lot of work in this direction. He is trying to keep energies together. I really appreciate. We can meet again and again, and I think together we can do a lot of work.
You see, once the age we are becoming 60, we may not move, but through webinar every day we can spend 1 hour. There is no problem. Through webinar, we are ready to share every day 1 hour for others, for the sake of our own team, for the sake of our own community.
Correct.
Okay, very, very pleasant talks from both of you. And really, it is a very wonderful evening. And all of us enjoyed your informative, knowledgeable talks. Actually, there is really very good depth from both the talks. And I hope all the participants might have enjoyed and learned the basics as well as the depth in the subject, in both the energy storage, magnetic mirror energy storage and their applications, and also rare earth materials and the lasers, applications of rare earth materials for applications of lasers and laser glasses. And I hope Professor Jayasankar may create the glasses rice also. Glass, because I came to know that the Chinese people are fabricating the plastic rice. I don't know whether it is true. Maybe sometime.
No. I am telling different types of lemon rice, curd rice. Similarly, there are different types of glasses. How that glass rice is going to be changed from one form to another by modifying the modifiers. Yes. Salt and lemon and tomato is the modifiers. Similarly, there is a borate, phosphate, silicate glasses. You can add some modifiers of alkali elements or alkaline earth elements or heavy metal oxides so that I can modify the glass. If the salt is more salted rice, if the salt is less salted rice, you are calling. Similarly, heavy metal oxide, less metal, like that. Keep on growing the glasses as many as we can.
Yeah, nowadays these glasses are replacing the precision stones also.
Yes, sir. That's what I'm telling.
Yeah. In ornaments, all the glasses, colorful glasses with the good faces are really
gemstones.
For the costly diamonds and all actually. Really wonderful talks actually. I now thank you both of you and for sparing your valuable time and sparing your knowledge to importing knowledge to all the people like us and all others also. Thank you very much. Now I request Mrs. Basamma to propose vote of thanks for all this webinar.
Thank you, sir. A very good evening to all of you. I have a great pleasure to propose vote of thanks. First, we would like to express our sincere thanks to Chief Guest Professor A. Jyoti Ma'am, Dean, School of Sciences, for spending her valuable time and addressing. Thank you, ma'am. We would like to thank resource persons, Professor V. Vasudev Rao, sir, from IIT Kharagpur, and Professor C.K. Jayasankar, sir, from SV University, Tirupati, for delivering very useful and wonderful lecture. I would like to thank our beloved HOD, Professor A. Sridevi ma'am, and coordinator, Professor M. Krishna sir, for guiding and supporting us to conduct this webinar very successfully. Finally, I would like to thank all my fellow staff members, students, and participants to make this webinar successful. Thank you, Ananda.
So now we close, sir. Bye.
Oh, bye, sir. Bye.
క్లోజ్ చేస్తాం సార్ ఇంకా.
Okay, sir.
Okay, sir. Session ended, sir. Thank you.
Yes.
Thank you very much. Hello, sir. Session ended, sir. Thank you. You may leave, sir.
అంతా మీరు చేస్తారు కాబట్టి కొంచెం ధైర్యంగా ఉంటారు.